Good afternoon, everyone. On behalf of the Entrepreneurship Cell, National Institute of Technology, Meghalaya, I extend a very warm welcome to our esteemed guests, respected judges, and participants to the Green Innovation Challenge and Summit 2026. So without further ado, we are going to begin our first presentation. The first presentation is from the team of Kapil College of Engineering and Technology. May I request the team to start the presentation? And kindly keep it within 5 minutes so that you can interact with the judges. Thank you.
Yes, sir, I will be starting.
Yeah, please start. As informed, please don't spend too much time on introduction and general data. Please tell us about your challenges that you have addressed. Okay,
Sure, sir.
please start.
I hope my screen is visible.
Yes, it is.
Good afternoon, respected judges. Sir, is Hari. I'm not going to take my question. We are presenting our project Aquasheet. Imagine you are standing in a lake in a city. Or if the source of light is actually covered in plastic and oil patches. So, this is not just an environmental problem right now. Now, it is growing into a public and sustainable piece. Today, the problem of the body are increasingly polluted, and the current treatment methods they are very manual, inefficient, and they lack the real-time monitoring. They are very slow, labor intensive, and they are not located at all. There are some existing solutions, but there's a gap. That labor is dependent. There's no intelligence. Like they can't really monitor everything that is been changing. We cannot access the data, what is being taken and what is done now. And it's very costly and they're using industrial. So we are going to present a solution, Akashi. What is Akashi? It is a smart autonomous water cleaning system. It is designed to make the water cleaning process intelligent, efficient, and data driven. It is also aligned with the sustainability development goals of developing clean water and innovation. I would like to call upon Ms. Kamala Gupta to explain the solution here. Hello everyone. So, building on where my topic is, let me take you through how abortion actually works in ways. At its core, abortion is a technique which means it can operate with water without any human control. What makes it powerful is its ability water or fish. It can identify plastic organic and with oil spills on a real time. Along with that, it continuously gases and sounds like a so that we understand what attention is, let's look at how the system works in the task starts with camera capture, where the bot collects real-time visual data from the water. This data is then proceeded using AI filing. Once the waste is detected, the system performs hard math to predict the most efficient route to reach. After this interactive, the collection can and stores the waste. Finally, all this information is sent to a data dashboard, allowing real-time monitoring and analysis. As you can see, it is a fully connected pipeline where each step feeds into the next, making the system completely autonomous. Now to summarize the whole concept of aquashield, let's quickly go through its key features. This is slide. Okay, so firstly, AI-based detection enables real-time identification of different types of fish. It is autonomous navigation, allows the bot to move efficiently with avoiding some forms. Third is stage collection, which means your description is done through familiar mechanism in storage. And finally is algorithm monitoring, which provides rapid environmental insights or safety. All these features together make a partial unreliable, scalable, and independent solution of the. Now I will tell hydrogen analysis.
Yes. I will also look at technologies to make the system that capable, accessible, and reducing sense of touch and sensitivity. Hardware offered by Raspberry Pi or hardware, a real-time dashboard using AI. The prototype costs between 10,000 to 30,000, giving audio and visibility. Each unit can collect approximately 3 to 5 kg protein per second. Moving to silver, it reduces manual labor and towards zero pollution to restaurants and enables person to identify pollution hotspot. Instead of one large machine, control bombs can be across different water bodies and monitor. In conclusion, aquaculture is not just a food system, it is a step towards smarter, cleaner, more sustainable cities. By combining innovation, we aim to transform how we create electricity. Thank you.
Thank you guys, that was very good. Two questions. Where are you, at what stage are you in this project right now? Do you have a prototype? Do you have started building? Are your design is complete? Validation is complete? What is your status? Sorry, can't hear.
Okay, please now.
So we just asking you, can you hear? You can hear us? Hello?
Are we audible to you?
Can you hear us? Hello? You can hear us? Hello?
But we can.
Okay, just asking you what is the status of the project? Your design complete, validation complete, prototype, what stage you are in?
Is it possible to just take the five books and serve this as seriously delivered from this
Okay, can you hear me now? Oh, it's a laptop mic, okay. I'll come to you. Can you hear me now?
Yeah, better. Thank you.
Better, okay. So what's the status of the project? Are you in design style prototype.
So this is just the idea that we thought, doing brainstorming of the college area or campus area. So we just got the problems around our college surrounding, and just thought of this, and our idea is really good, and we are going to this idea.
Similar concepts are out there already, many. Some of them are already deployed. What is the difference you are trying to bring that would help in a particular aspect?
Sir, our solution is actually combining data and AI detection and autonomous navigation as well. So it is giving the data analysis unlike the traditional systems.
Okay, thank you.
Yes, ma'am. Yes, ma'am.
If I have to make this technology more inclusive, can you tell me which is the lowest straight out individual perspective that this technology involves boundary? From your setup of manufacturing, can it come down to individual level? Yes, what's the process of this?
I am really sorry that your voice is be breaking. I didn't really understand.
No worries, that's okay, that's not the fault. Am I audible to you now?
It's still breaking, but
Okay.
No, let them know.
that so we have to say it over here and you pose the question on WhatsApp and do right. Okay, so the answer should be on WhatsApp. Thank you.
Thank you so much, team. Next up, we have the team from NIT Meghalaya.
Good afternoon, respected judges and everyone present here. Today we are going to present our project titled Smart Energy Generating and Self-Healing Footpaths. In cities, towns, schools, stations, etc., large number of people walk every day on the footpaths. They are an important part of our urban infrastructure. But traditionally, footpaths have many problems. Over time, they develop cracks, wear outs because of the continuous use and require frequent maintenance. Thousands of people walk on them daily, creating pressure and movement, but all the energy is wasted. So we ask ourselves questions. Can a footpath do more than just providing a walking surface? Can it become a source of energy? Can it repair itself? can we support sustainable cities? This led us to our idea. Our proposed solution is a smart footpath that can generate electricity from footsteps and also repair small cracks automatically. This means that footpaths is no longer just a pathway. It becomes an active, productive, and green infrastructure system.
Now let us explain the first part of our project, which is energy generation. So our idea is Piezo effect. Piezo effect materials have special property. When pressure is applied on them, they generate electricity. So we want to apply that idea in our project, where when people walk through the pathway, they will create some pressure and through their foot to the pathway. So we will just convert that pressure into energy. And then coming to the next part of the project, it is self-healing technology. So the major problem is normal footpath is cracking, small cracks slowly becomes bigger cracks and then ultimately damage the entire structure. So to solve this problem, we propose the use of self-healing materials in the footpath. These materials are designed in such a way that even small cracks it appears, they detect it and repair itself. So that's the idea for our project. And finally, the two projects focus on two smart features, which harvest energy from footsteps, and the second, it reduces structural damage to self-healing capabilities.
Our ideas has a few main components. First is a piezoelectric sensor or plate, which converts pressure from footstep into electricity. Second is a footpath surface layer, which people walk on and which transfer pressure downward. Third is a material layer, which helps repair small cracks automatically. Fourth is an energy storage unit like battery, which stores generated electricity. Finally, the wiring and the control circuit helps collect and transfer the energy from useful output like lights or sensors. Now let us discuss the benefits and expected outcomes of our ideas. The first benefit is clean energy generation. Even though the energy generated may be small per steps, it can still be useful for low power application, especially in crowded areas. The second benefit is reduced maintenance cost. Because the footpath can repair small cracks automatically, the number of repair needed over time can be reduced. The third benefit is longer lifetime of infrastructure. The footpath remains stronger and more durable for long period. The fourth is the better use of public places. A normal footpath only allows movement, but our smart footpath adds extra value by generating energy. The fifth benefit is environmental sustainability. Less repair means less material use, less waste, and lower environment burden. Moving forward, this is a green technology because it's focused on sustainability. It uses human movement, which is naturally available as a clean energy resource. It reduces dependence on conventional electricity for small urban needs. It reduces waste caused by repeated construction and repairs. It promotes efficient use of infrastructure and supports the idea of smarter and cleaner development.
I think these are okay. Go to the next one. This is okay.
One challenge is that each footstep generates only a small amount of electricity. So the system works best in crowded areas. Another challenge is that high initial cost of installing smart material and piezoelectric components. There is also the challenge of making the system strong enough for long-term public use. In addition, self-healing material and energy storage needs proper design to work efficiently. So while idea is innovative and sustainable, practical implementation needs careful planning and improvement. Now the implementation plans.
Our pilot program begins with building a small prototype model to test whether footstep can generate electricity. In second stage, we test the noisy electric output, durability, self-healing behavior. And in third stage, we implement that plant or system in a small area where the traffic is used. And for the final, after the results are positive, scaling it to larger mass media.
Since the setup cost is high, it may time to recover the investment through energy saving and reduced maintenance. So for strong ROI, this system should be implemented in high footfall areas where both energy generation and long-term maintenance savings are higher. We have also included Japan technology perspective in our presentation. Japan's technology involves embedding piezoelectric ceramics or polymer material under flow tiles to convert kinetic energy of footsteps into electricity. Piezoelectric floor tiles are installed in busy areas, most notable at Tokyo and Shibuya Station, where millions of passengers pass through daily. These tiles are often placed around the ticket gates to maximize the impact of footsteps. When people walk on the tiles, the mechanical pressure compresses the piezoelectric element, causing a small electric charge, around 0.2 to 0.1 to 0.2 watt per step. The energy generated converts in less wiring loss, etc. Japan is a major hub for advanced microencapsulation technology, holding about 14% of Asia Pacific market share. Japanese firm focus on high performance applications, including controlled release pharmaceuticals, functional textiles with aroma and specialized food ingredients.
Yeah, I think we should wind up. Please try for question. Huh?
Sir, we have lots of time.
Sure, please. Yeah, that's fine. While that is happening, go back and look at again the same question. What stage you are in? Yes, we will design.
This is just an idea.
Idea. So you are sure that people have done. Yeah.
The microencapsulation method and the piezoelectric material method, they have been separately in Japan, but we are integrating them for the very first time.
That's called PNG technology. We use for various. The question for you is you are trying to solve an energy problem, correct? In your statement, you are looking more towards cost and money, ROI you have to, right? And you are looking at how much cost. I think since you are exploring, instead of ROI, use ROE. ROE is return on energy instead of return on investment. See how much energy that goes into making those and how much time it will take for you to get that much energy. Okay. Please do that calculation. It will help you, if it works, it will help you sell that.
Thank you for advice, sir. We were also focusing on the reducing the maintenance cost of.
Right. The second one is heating.
Yes, yes.
And you talked about some bacterial.
Microencapsulation method. We are
Definition of what?
using that mechanism. We are using.
Microencapsulate what?
We are we are using microencapsules in concrete.
Sir, microencapsulation in pharmaceuticals, functional textiles, aroma, or food ingredients. So it is mainly made up of polymers, lipids, taxes, etc.
So, good concept. Think about how practical it is. Okay? Good. That's all.
What's the status of smart city project in India? What is the status of smart city projects in India?
So it is in the growing phase. We haven't read much about it. We are studying.
Spends time on it. Understand the nature of investment and funding themselves. And what the challenges are that there's a high way of embrace that you have to
I'm very non-technical, this is a very good question. When you came up with this idea, what was the diaspora that you had in mind? You understand the answer, you have an understanding of the word diaspora? Very good. What is the target population you have in mind? My example is Japan, where I'm sitting in Himalaya, where every day the business goes to Kolkata, every third month there is a fully paid road that gets completely off because the PWD does not have any communication with the motor line. So, is it feasible for me sitting out here? Is this technology feasible for me to be applied in the major segments of India? Is my next question. And if not, I completely understand. I want to know a psychology of what target population we're talking
Ma'am, it is not feasible everywhere in India, but while we thought of this idea, we targeted the smart cities, metropolitan cities, which have a large population, and we targeted specific areas like railway stations. Like it will take a lot of time in development because our country is not yet ready for such a plan. But because our country is taking initiative towards sustainable development and green technologies, so in future, this can be implemented in railway stations, in metropolitan cities, in public places like parks and everywhere where partners are used a lot.
Fair enough, fair enough. That is actually a transition. So smart city first and then the smart city. Fair enough. There's another advice also that I would be giving you for future references. Darling, whenever you want to give a presentation is not reading. There's a difference between you presenting something to me and reading. Yeah, so get out of it's your brain side, right? Get out of this device and interact with people more, gives you another symptom. Just an advice for any generation to be given. Great work.
Thank you so much.
Thank you so much, team. The next team is from SNS College of Technology.
Guys,
Alright, so now we will move on to the second team from NIT Meghalaya.
Labon,
I audible?
Yes.
Sorry, sir? Okay. So I am very prepared. So let's start with the question. When did you last saw plastic bottle?
What?
Right now? Yeah. So is there any novelty in this? Any
Novelty in what?
plastic bottle? In plastic bottles.
Bottle. Novelty is
I agree. So the thing is, the idea, how it came to me is that there is a beautiful stream outside of our campus. You can go sit there, it's very peaceful. You can see some birds. So the thing is, I was sitting there with my friends. In fact, Saiful Shah, he is also in the team, but he's absent from here. But what I saw is, in the beautiful stream, there were lots of plastic bottles, and it looked very bad, and it was polluting the whole thing. And for that reference, that is the stream for 764s. Okay, so the idea is we want to build. It's not a new thing in this whole world. There is DRS system, I heard. It's in Germany, but it's quite analog. You have to connect all the portal, then give it back to you. It is the vending machines. In India, there are some companies, they're also doing the same. They have vending machine in different distributions. So, but what our idea is, we want to decentralize. It is B2B businesses. So we want to come to B2C. So what we do is we build an ecosystem with local retailers, and we will have a unified system, an app maybe, and it will give you instant cashback if you return your phone, so you return your plastic bottle. So how does that work? For example, you bought that bottle. So if you inherit Meghalaya, beautiful place, you don't want to pollute this place. So you take a bottle, you bought it, the bottle is 10 rupees, but you are buying it at 11 rupees. Now there is a catch. You will return that bottle to the retailer. He gave you 2 rupees cash back on that. So effectively the bottle is 9 rupees. India being a very price sensitive market, that 9 rupees bottle will be very effective and give that what you say, customer satisfaction, instant gratification, whatever you want to say. And people love cashback in this country, and we believe also we are trying to create a unified ecosystem where there will be a leaderboard. For example, you are in Shillong, and you can see your friends how much they have earned from that cashback scheme, and also the whole country. Like there will be whole leaderboard sections of that. That is our initial plan to create a customer instant gratification competition for recycling. But the question is where, how the company will give them 9 rupees. The thing is, the company is paying a lot of money in making that bottle, also taking it back, recycling. Soon there will be time when there might be introduction of carbon taxes and all that. So company might want to buy the carbon credit back. So that can be a great way to get the carbon credits, and also the business model supports efficient recycling of the bottle. India has some high quality recycling processes, but they're very decentralized. So what we want to do is we want to bring that together. And one thing also, so we want to give the retailers or the lower level retailers something back. So what they will get a percentage, suppose 105 for a bottle. So for 100 bottle, they will get 50 to 100 rupees. That is the expenditure from them also. So it creates overall ecosystem for everyone. I'm very sorry, I'm very eager, but I don't have anything prepared for that. But it's my idea that recently the arguments too.
But how will you connect all these people?
So sir,
How will you connect all these people?
So that's what I'm saying, that it is ecosystem, right? So we have to connect with, like for example, this side. If you are want to get into the market, as I said, India is a very price-sensitive market. So if you want to get into that, you have to get into lower prices. But you are not giving it lower prices. You are technically giving it very marginal lower prices, but you are also getting back the bottle in a very less price than you are getting from the vendor. So what we are getting it, we need government initiatives, because you see government is also trying to get rid of these bottles and found a way, a clean way to recycle all this. See, if you go to a dump, you will see. If you are in a dump, you will see lots of bottles and and when they burn, they smell very bad and all that. And also you can see people, young people, young generation of people who are child laborers are there. So that is a matter of concern for government also. So we want government policies for that also, and a unified measurement has to be done by the individual level also.
Government policy for what?
For implementing these measures, because you see we are helping in a lot of ways. Like the dump in the dump there is less plastic bottles, because a plastic bottle can be recycled for 5 to 6 times. Yeah, but it is very rarely it is going to 5 to 6 times in that second. We have created 9.5 billion ton of plastic bottles in 1950s. Only 0.5% or 6% has been recycled. So it is a major problem and bottleneck for everybody. So we are just bringing that easier process of recycling.
Good idea. Forget about government intervention and we go about connecting the people.
Connecting the people. So see that, as I said, the retailer will be getting some amount of money. So he is
So
being
how are you going to catch the retail?
Huh?
How are you going to catch the retail?
it will, as I said, it will be the ecosystem.
I am a retailer.
Uh,
I'm sitting somewhere in some village. How are you going to find me?
So, see, UPI was something that was seen a very high-tech innovation, but it has reached the grassroots of India. Right? So if we can implement it correctly, if we can reach the target audience, it will reach it. And India has.
Your idea was good. Now you are skirting my question by saying connecting to UPIs. What UPI, how we implemented and how you are going to implement, there is no connection. So, I am very simply asking you, how are you going to connect to the retail? Rather than saying UPI did, I can do, no.
So by connecting to UPI, are you meaning that?
I use UPI because I want to buy.
Right, exactly.
Now, why do I want to connect it? First of all, your idea is.
Okay, I understood your question. Let me tell you that. Are you saying that what is the incentive for the retailer? Or something like that?
Yeah. How do I even connect? How do I even know that I need to do this?
First of all, as I said, you are getting 150 rupees for 100 bottles. If you get 1.15,
That's a financial.
it's a financial gain for them. Because as a small business, you do care about 150 rupees.
Okay. Makes sense.
I have a query, short question, I have a query. To be honest, it's very nice to see that someone is technology advanced. Really nice to see that. You have to think about when you say I want to create a system, you also have to think about want to create and if it actually can be created. So connecting to your target audience is something that you can go through. I just wanted to know one thing, are you restricting yourself to just drinking water, PET bottles, or this can be in your headspace? This can be extended to all of the cool drinks, all of the other bottles as well. Are you keeping that in consideration?
Yeah, because all of them plastic, but the thing is, then you have to segregate bottles because
Yes,
there
the
are
reason
different
why
bottles.
I'm asking this, that if it is just the drinking water bottle, we are talking about adults and adults, right? But if you take into consideration cold drinks or those sweetener drinks, it is same. We bring in the largest population of the consumers who are the kids. And technically kids who are from, if I take in terms of classes, they are from standard to 7th standard. They're the biggest consumers. Now money may not be an actual incentive for them. So you need to think about what incentive is to the different categories of people who you choose to make a part of the ecosystem. This financial is only for adults. If the technology is also for children, money may not be available when the parents see, but not very. And because you take into consideration an app, again, they're already hooked on digital device for sure. But if you put in a competition, you remember the Pokemon Touch, the Poke Free, something like that, it's an advice that something like that. can also work. Do not just stick to the financial incentive because it might work for one category of people, but the people who will give it back to you may not always be driven by financial considerations. So this is golden advice, and it's just good to know that we've started. The idea is not this, truly is.
Thank you.
So how do you come up with the solution? What was the thinking process that when you thinking about this as
So one of my brother is in Germany, so we once talked about it, like he collects all this protein at the end of the month when he is in the super shop. Later they give it back to him. So as I said, last week, my friend, I have tried to smoking, so smoking this. When I was, and it was really looked bad. And so we thought that why not in India, or why not in a place where digitalization has been so good. I mean, has reached that much gas level, you can connect with anyone, you can pay with anyone, so it can be easily connected. That's what my thinking process is. Well,
Okay, next.
Thank you so much. Next we have SM Adarsh from IIT ISM Dhanbad.
Is my voice audible?
Yes.
Yes.
Hello. Are you audible?
Yes.
Yes, you're audible.
Okay. Go ahead. Is our screen visible?
Yes.
Can we start?
Yes.
Shall we start?
Yes.
Good afternoon, everyone. We are Team Eco Innovators. Sorry.
Go ahead, please.
Good afternoon, everyone. We are Team Eco Innovators.
Somebody sit there and talk, huh? Say, somebody should say.
To understand the problem state, to understand the solution and why is it existed, we'll first look into the problem statement. The current framework of wastewater management is highly unsustainable. As it is of a take waste model, and the 75% of expenditure is spent on only the capital, basically the infrastructure, rather than the actual treatment of the wastewater. And it is also an energy intensive process. It increases the consumption of fossil fuel.
Yeah. So now we are seeing the impact that our proposed solution is going to make on the SDG, Sustainable Development Goals. So the most important SDG related to our project is clean water and sanitation. This is also fundamental right in our country. So this is the important SDG that we are doing. The next comfortable and current is very energy intensive and it is
Just a second. Just a second, hold on.
energy and not productivity.
Hello.
Third SDG, good health and well-being.
Hello.
Yeah.
Can you get into what is the solution that you come up with and a clear common definition? Because if the SDG stands.
Okay, so you just want a solution, right?
Yeah.
Yeah, sure.
I mean, you can skip the SDG definition slide.
So now let's directly proceed to the solution part. We propose a smart, circular, decentralized, energy positive sewage treatment plant. So
we propose the key features are decentralized features. We directly bypass the costly and the most infrastructure intensive centralized people plans. So it is directly reduces so much of the cost. Next, we propose we are trying to use AI and IoT integrated for automation of the whole system. In this, does also we are on SAP will also be energy cost system. Here, we will produce more energy than we will utilize. Next, the most important thing is net zero water. The treated wastewater will be almost utilized almost 90 to 95% efficiency. Yeah. So now let's dive deeply into the key features one by one, starting with decentralized treatment. So why are we exactly doing this? 75% of the capital expenditure is mostly spent on the infrastructure of the centralized treatment plant. So so instead of the money this needs to be actually spent on the things required on more research is being spent rather spent on the capital or is mostly spent on infrastructure. So we have come up with a decentralized treatment plan. Here, instead of transferring city or the whole city, we will treat it locally directly near the source. This reduces infrastructure costs, saves energy, and eliminates the dependency on large pipeline networks. It also avoids the system-wide failures, making it more reliable and scalable.
Now let us look into how AI and IoT can be integrated into this. The traditional system rely on manual operation. That is, if the whole system has some issues like clogging of membranes or some chemical imbalances, the whole system might fail. To solve this, we can install IoT sensors to monitor several parameters like pH, COD, POD, and we can train the AI system to control the flow rate, temperature, and other important parameters. So by this, we can increase the efficiency and the yield of the.
Okay, so now this is the main process that is the anaerobic vector reactor. These vectors are kind of membranes that are going to export and the water is forced to pass through these vessels and thus increasing the efficiency of anaerobic digestion. In anaerobic digestion, methane is produced. So we are going to capture this methane and this methane can be used mainly in two ways. We can supply this methane to nearby households and this methane can be used as a cooking fuel. Another thing that methane can also be used to create to convert it into electricity. Another thing is sludge is also removed continuously at a particular time interval and this sludge can be dehydrated and then used as a very good organic manure in organic farming. Now, the net zero water loop. This is most important thing as we are using the treated water as a resource. We are again pumping the water which is treated to the household from where the wastewater is. This water is used for non-drinking purposes.
Now let us compare the centralized STP with the proposed STP. In centralized STP, the infrastructure cost is high, but whereas in our proposed STP, the cost is minimal. But the water recovery rate in our proposed STP is quite high, about 95%. But and our STP, if we talk about the energy aspect of our STP, we produce energy, so making it an energy positive system.
Now let us see about the impacts and the most important, the economic impacts. So let us assume that our plant will cater to a community of 15,000 people. People drink about 1.8 billion liters of sewage water per day. assuming an efficiency of 90%, we can recover around 1.62 billion liters of water per year. And we can generate around 1,440 kilowatt hours of energy daily by using the solar panels and the biogas which we produce. So out of this, if we reduce all the electricity which we will be using for running the plant, it means around 1,000 kilowatt hours of surplus energy. So financially, in a year, we will be saving around 3.5 crores per year. So, in assuming that we have total expenditure is around 8 crores, our payback period will be around 2 to 2.5 years. So, in just 2 to 2.5 years, our amount which we spend will be around equal to the amount of our revenue. So, after 2 to 2.5 years, we will be under profit. So this clearly shows that it is both economically feasible and environmentally viable. So using our SAP, we can also reduce around 420 tons of CO2 annually. This model, when it can also be scaled properly. If first we can start with a few plants in the region and then slowly scale it to many other locations. So we have a proposal. We have in a year we have.
Hi. Can you just pause for 1 second? Yes? Yes. So just ensure that this is your last slide and you can have the conclusion drawing line for exam. We're just giving you that time to prepare
Actually, your voice is not that clearly audible.
No, so we just want to conclude with the final summary. General details are not required. What is the main thing you are proposing is what was required. Okay, please conclude.
Not that actually both are in group like in also group because we are able to clear properly. That's not a background.
Okay, all right. We'll send the questions on that.
Yeah, sure.
Thank you.
Can you send a message to this group that how to connect your experience that is not what people, just what is the real need, what is the proposed solution?
So to continue, we are sitting on the system that leads we are based on the asset base to the one that leads in asset. Our solution can achieve net zero water usage, energy cost of operation, and a smart and sustainable infrastructure. This is a step towards future ready cities and a circular economy. Thank you.
Okay, thank you. Next.
Thank you so much, team. Next, we have a team from University of Jammu. Please present.
Thank you. Yes, we can hear you. Start, please.
Go ahead, please.
Good evening, everyone. So we are here to connect from the news from Dr. Anand Sharma. So India has already faced about 3.58 lakh people as celebrated every day, every building. So we walk and get commuters as the others, Patna and Guwahati. Not one business plan has ever used from Patna. We are quiet and we build plants. The Western satellite images involved at 13. A village name is provide invisible and maintain existing hierarchical other in more to buildings walls because they could tell the wall for certain engineers plan to make India's 1.4 lakh crore and television budget that we get every morning. The data to solve this is the analytical layer does not handle not. If I had a word, so many more output into flood intelligence to the MMTR data set. No new service, no new project. 3 AI year, speed, simulation, and system. We can start every day, road and rain, and 91% accuracy. Simulate, predict, flood threat with 3.3 centimeter mean error using a real transfer of physics informed ground real level calculated on its the brand situation. Calculated on 500,000 real field points. The rating power is getting zero hydraulic productivity. So water physically cannot move through water. The steam generates millions of only combines carbon rate for farmers. The first credit in 12 to 18 months post deployment.
Now, I can see the other question here. So, यहाँ पे हमारी means आई हुई है तो 90% का water volume asked to be expectation 98%. अब जब आप यहाँ पे हमारा output देख सकते हैं, यहाँ पे तीन roads है, building है, अलग हो जाती है, जो अपना अलग क्लासिफिकेशन मतलब हमें पर्सन वेयर द मॉडल में जाता है उसके को हम बिल्डिंग के आने चाहिए और जो उसके बिल्डिंग के अलग होके आ रहे हैं ये और यहाँ पे देख सकते हैं तो आप एट वन ऑफ सर्वे के यूज कर सकते हैं यूज बिल्डिंग उसके बाद सेकंड हमारे यहाँ पे वेयर क्लासिफिकेशन आ गई तब दूसरे से एलिमेंट बनाते हैं इसके बेस पर देख सकते हैं कहाँ पर मॉडल की हो सकती है हमने एक लाइव को किया है करिया बिल्कुल कैसे कोलैबोरेट करके वहां पे बिल्डिंग है ऑप्टिमाइज किया 3 और 4 पॉइंट कंस्ट्रक्टिव में जहां पे हम बिल्डिंग है ऑप्टिमाइज करते हैं और अब ये हमारे वर्क है इससे हमें देखिए हमारे पास ऑटोलॉजी कहां पे है इसमें हम डिटेल एडिशन कर रहे हैं उससे हम कोई ऑर्गेनिक कार्बन ट्रैकिंग उससे कार्बन एडिशन करते हैं फार्मर्स को तो हमारा रेवेन्यू बनता है
Of course, in 45 minutes versus 6 to 8 months time. Emergency response time reduced by 60% to feature column. A blue cost from 60 to 80 to 3200 first the table as farmers producer of pre-working care systems validate on blue processing data, not limited, not but solving the intelligent problem is only half the case. 87% of the machine learning models that are trained are never deployed. Adding to benefit and that are deployed. Even in our activity used in operational workplace. The last one is more effective than the bad data ever. 92% accurate flood models that no computer can 0% accurate flood model in that. What happens after the model runs? This is the output. However, the drainage engineer in the district office turns up the flush stream pipe to do future flow. Without knowing what the quality is, our GIS was 2.4 meters away. It's months to learn and had zero native AI integration. Huge AI is free, but requires deep IT skills. Both with the same current maintenance every day, whether you are a surgeon, a hydrologist, or a chartered. This is not a software guide, and this is a category. There is like a different system of formed from the ground up with error integrated both between professional workers. And the understanding no server, no IT partner, and location. A production GR25 can connect new types and right into the hard good culture, since not just tasks to start render in real time. Then I write the problem for a concept of formula. The guide is in the result is in so we have to just notice the little data will run the head in 45 minutes and when it is blood test amount, previous CPR and a carbon test. 0.5 and 0.6 most even just without government engineered it just in short-term memory. That is the cost which you have to make this employee in actual mathematics. 3.20 lakh have to you don't change that by making better models. You change it by making models accessible to people who have never probably used it. The better guide is okay. Standards variety is the highest. I think flow data scale on the smart level. These three working systems one should deploy as less and validating the resilience data and reliable become solid. And what we need is a pilot user partner. If there is anyone in this room from an other local body, either or the smart city program or the state task management authority, the data is already there. We have built everything.
So now we can see that everything we discussed for the technology part. Still that of we can commercialization as a transform of market input. So with this we can see the computer analysis ecosystem. Like there are different variables, like size, accuracy, analysis, output, release time, and carbon reduction. And in all of that, for various parts of it, output on the average, we can see time which one is related to 8 in 45 minutes. So we see where everything is manual. 2 centimeters of height. In terms of religion, everyone is also manual flow. Here is clearly common. And in terms of and coming to various lines, everything in the old tradition from the limited. It's not, but we have. In terms of carbon revenue, no one is working. Just the technique of the satellite class, 88 cloud as now. We have parallel areas fully integrated and with the market solutions, which we are ready to deploy. And also we have filed 3 projects for this solution. Every year we have 5 patent and continuing in process of pitching into ministry. Also we have collaborated with system of Jazira taking to further scale at a pilot level of the national level. And now why the parallel areas is why are we taking? Because also data files is what was underutilized. We have added this to utilize that data for further better way. And we can see we have a relationship with like DPR and it is more to be what we can. And this is how parallel experimental tests you can see. And this is the business model is how we market. First of all, we have commercial system. So this is the team. So we are consisting of hybrid team technology as well as management. From management and father the initial development of technology. So we are collaborating.
Nice, thank you. Just have a question. What are you going to do after the resolution of 3.5
It's 3.5 centimeters. It's a point of LiDAR data. It's a 3.1 of LiDAR data. And so we have the 3.5 lakh so in what forming to us, in which medical professional takes that data, 3.5 centimeters accurate, no data from villages.
So again, the data is already available. So
Yes.
Government agencies already have this kind of data at their disposal. What is the new thing that you are bringing in there?
We are adding intelligence system because the data was basically underutilized. That was used for land access. But we have added that.
That's all questions.
Thank you.
Okay, thank you. Next slide, please. This was
Thank you so much. Next team is from Northeast Graduate University.
Which university is this from?
University You are 50 teachers, right?
Okay, from the start. Say start, huh?
Yes, remember the enter the cities. My body.
You're not taking your hand.
No, I am not.
Ready? Right?
Reading the list. We are Team Starlings. Reading the list. We are Team Starlings and we are representing Northeastern University, Shillong. So, we are going to present our project. It is named Green Pulse. So, what is Green Pulse? Green Pulse, it is a real-time ecosystem health monitoring system designed to move passive observation into an intelligent environment protection. Ecological sensitive areas. Like, there are many ecological sensitive areas in Shillong, like Cherrapunji, Ubin Lake, root bridges. So they are facing serious degradation issues due to unregulated tourism, human interference, as well as lack of continuous maintenance. But the real issue is not absence of data, because there are many government facilities that provide data, macro data, like temperature, humidity, and different types of data. But the problem is not lack of data, it is lack of decision making. Existing systems, they collect and display data, but fail to integrate and respond in real time, which as a result, environmental damage is detected too late when it becomes dangerous. Now, problem is clearly visible in regions like Cherrapunji, Ubin Lake, root bridges in Cherrapunji, etc. They are caused by increasing human activity, which is silently affecting the ecological balance of that particular area. Now, to address this issue, we propose Green Pulse. Now, what is Green Pulse? It is an IoT-based system which not only monitors environmental conditions in real time, but also analyzes and integrates the data to provide meaningful insights. The core of this program, of this project, is EMS, which is a short form for economic score. Now, what is EMS? EMS is basically a scale, simplified 0 to 100 scale, which converts complex environmental data into a simple, understandable score between 0 and 100. With this, you can also scan the QR code, which is here. Right? It is a website which is it's a student website. You can see the current status of this particular area.
3 plus 1 to 3 dots in the chat.
Absolutely.
Super. Okay. Next.
Okay, so now we move on this.
15.26. Where did it pick from? Oh, it's changing as you speak. So
Yeah, it is a real time system. It is a real time
So I
system.
am the loud guy here.
Okay. So now let's go to the system workflow. How the system.
In our here, I mean, if you put from the device itself.
Yeah.
Hello.
You are not louder than me.
Hello.
Okay. Okay, move on.
Okay, now let's move on to the system workflow. Like how the system is working. So at the core, we have the sensors. For this prototype, we are using two fundamental sensors. One is LM393 sound sensing module. Other is LM393 soil motion module. Now, what these sensors do? These sensors collect real-time environmental data and it sends to the Arduino, and the Arduino sends this data to our Python-based processing system through serial connection. Now, when the data reaches the Python code, the data is normalized, analyzed, and converted into a simple EMS value. And that values, they are after computing, those values are uploaded to a cloud-based, Excel-based backend using Google Sheet API. We can also look at it. So this is backend we are using. This is simple, like it's continuously monitoring this like 2-3 intervals, 2-6 seconds of interval. Okay. Now after the data is transmitted to the backend, a web dashboard using Streamlit visualizes the data and provides actionable insights along.
I think it's all good. You have actually touched the raw nerve by showing something that we can see interact. You've done a good job.
Thanks.
Okay. Don't want background. I don't want to look at your code. I don't want to look at how do you connect the Python, how the things not.
Oops.
Tell me what do you want to do next.
Okay. Now next, I need to Vivek to explain what makes our system truly intelligent.
So that's okay. It's intuition. So we are
If we talk about what makes our system intelligent, it has ability to go beyond simple monitoring. First, it analyze the live income data and detect the change and anomalies in our environmental conditions. For example, a sudden spike noise level may be overtopping by the normal soil reading. So the moisture of the soil that may signal to environmental stress. Based on these patterns, the system not only identifies the program but also sends real-time alerts with the recommended actions in form of not in form of notifications, but we will like further. This allows the authorities to spend immediately instead of reacting after the damage is already occurred.
Great. Done, I think. Move on. Don't want to, whatever you rehearse, you don't have to tell. Don't worry. Go to the next.
If we talk about innovation, unlike traditional applications, our application doesn't focus on your visual data. Our system is a multi-layered, use a multi-layered intelligence approach.
You understood the architecture.
our system works on localized high density data rather than the general data. It provides clear dimensions and accessible insight instead of just displaying if we talk about feasibility of system designed to be practical and stable, the sensor we use, they are very low cost sensors, and we use the Python libraries and Python tools, which are easily deployable. So that we can deploy data across the forest to the places and protected areas like wildlife sanctuary parks. If we talk about impact, we aim to enable early detection of environmental degradation, support better decision making, and promote sustainable tourism.
Next.
Let's conclude our presentation. Our aim chemical transform environment wanted from passive or observation into proactive.
Very good. I have two questions. Three of you. Which branch you are?
IT.
Huh?
IT.
All are IT.
Yes,
Who did what?
Sir, I did I am interested in Arduino and stuff, so I kind of learned this stuff quick, so I made it rotate.
Very nice.
And he and he might have another Python program and distributed it.
Very nice. You've done very nice. The presentation is very good. Many of the projects works fine, but when you go to do the presentation, it fails. But that also you have got. You've done a wonderful job. No question. Just one suggestion. Move away from Raspberry Pis and Arduinos. You are IT guys. You just have to collect some microamps from a speaker, right? Or a mic. So try to make your own PCB, which is more industrially stable. None of the Arduinos are stable. Okay, good for showing it to somebody. So you have done all the hard work now. Go back and do your own PCBs. I think this is a very good. Just the fact that you guys think the sound is a solution is a very good thing. You are positive for that. Okay, you done good job. But who will buy this?
So basically, this project. This can be purchased by various kind of tourist organizations.
Why? I don't care.
Because what can the tourist agencies they might get the one which provides our want to provide a good experience with the tourists. They can purchase our features and they can monitor the data. Like for example, there are two tourist buses. One bus will go to A, and the other one will go to B. If both buses go to spot A, then both tourists will experience overcrowding itself. But if one must go to A and the other will go to B, then both will face lower overcrowding index. So then the tourist agency that which place has a lower overcrowding index. Our this project is the first
good thought process. We will little more, and then definitely this is a good thought. Okay. Sure. Very good.
From the ninth slide directly there. So this is the basic slide here. So here we can see the various places in which
also. Very good.
yeah, there are various places we can start. Here in Shah, right now so in here you can see all the spots in surrounded with the tourist will be windows. For example, now tourist was but here we have this specific famous for in this building. Here we have the live weather forecast of this, along with soil sensors, the earth sensors, which are very useful. So for example, this is a sunrise soil, and here. I'm sorry, this is what? This is some rich soil.
Much percent, and this is price percent.
Yes, so it is actually there is actually in this language. So from the subsection it actually
Take it back.
so this is actually
Take it back. Take it back.
Super.
very nice.
Thank you.
I have just two queries, not questions, queries. One, who is this for? Who is your target and who? If you have to pitch this, who is this for?
This idea integration, this is targeted towards government organizations like forest departments.
So have you, if I have to rate you, 1, 2, and 3 yourself, at which level are you at the development phase? Of which are the first, second, third?
We are still at the second level because we are still planning on improving the system.
So in post the third level, you plan to reach out to the municipal environment controls. Get in touch with me after this live. Get in touch with me after this totally is over, or get my contact. Yes, because I see something which is visibly working towards it. If you can give me an activated role after presenting is done, this is something that can be taken. Because at this moment, I don't know what other places they are their plans. Good job.
Very good job.
What would be the cost of executing this or generally, sir, this will be like it's a possible set up and build a segment. But looking at the prototype, I don't know cost from like 200 rupees. This sounds as financially sounds as this cost around 60 to 70 rupees. And this soil unit is also around like 60 to 70. So, and as we further add our other macroeconomic measures like temperature, humidity, CO2 sensors, which can get more accurate this EMF fertilizer. So, overall cost will be like within 1,000 rupees.
Thank you so much, team. Up next, we have Palo University. I request the team of Palo University to kindly start their presentation.
Vadodara. Hello. Mark, from Vadodara. Arun University. Are you online? Black coffee. Oh, yeah. Okay. Arun University is not there. Can we go to Deshbandhu College? Hello.
That's it.
Milind Sahu.
I'm audio. Audio.
Yeah, you're audible.
Okay.
Good afternoon, everyone. My name is Milind Sahu, and I'm a first year BSMS here in Institute of Science, Education, and Research. And today I'm going to present exam lines in front of you. Now, coming to the problem statement, every summer in India, transformers, TV faces blackout, maximum from demand and distribution companies lose hundreds of crores in energy efficiency. But the main problem over here is not the electricity consumption. It's what is causing the spike in electricity. So we made a system that analyzes and monitors the energy consumption solution on the basis of that. So India has been installing around 250 smart meters according to national smart mission. But the utilities are using less percent of the data they have collected. So once the electricity enters the home, they see 5 kilowatt consumed. They don't see what's causing the spike. Was it the old system they see? Was it the charging spike or was it the transformer? And this is the bandwidth gap that we are trying to solve. So in the software side, we make a full system. First is an engine which consists of 4 machine learning models, random forest, gradient logical integration, HMM, and LSTM. All trained on 50,000 datasets of UKDS servers. Layer 2 consists of consumer intelligence, which includes monthly net forecast, appliance breakdown, solar optimization. Layer 3 consists of industrial intelligence, which consists of demand side prediction, economic forecast, forecast, and monitoring. And layer 2 consists of grid level intelligence, which consists of transformer overload risk, base imbalance detection, and targeted demand side intelligence. Into the 3D models I explored the diagram of the hardware that we have created over here. So this is our mini system. The device measures the voltage and current using the SCP sensor and ZMP sensor. Converts them to a digital signal with DC converter and processes them with an ESP32 to extract electrical signal. And this is the blender view that we have created. Now this is the smart plug that we have created. This smart plug does the advanced current using the ACS thermal sensor, processes the signal with the ESP8266 model, controls it to a relay model, and sends real-time energy data via buck to the AMP system for intelligent energy monitoring and control. And this is the 3D model of that system. So now, to the implementation that we have done till now, we have partnered with the electrical engineering department of the ISO Tirupati to work on 60 residential inverters now to achieve the TRF 5 stage and validate the prototype. The pilot testing will be starting from the next week onwards, and this project has already gone in 2 phases. First phase is the ISO CPSC summit, and the IT will be started. Now I have to show you the software side that we have created. So here is the dashboard of the system that we have created. The model has a score, F1 score of 94% and is trained on 5 models. The consists of 5 systems, and due to time constraints, I would like to show 2 of the main systems covered. First is the industrial system. So the industrial system consists of anomalies for state and industrial in kilowatt consumption. It predictively predicts the maintenance error in time zones and also predicts the penalty that a company need to pay. So it predicts it in future and the current demand contracts. It also shows the system health of the system, like the transformer health and the power factor index with the vibration index and impact index. Apart from that, it also shows the shift that might be needed to save this peak shaving. So, so you can see over here, the suggested shift is around 78 kV and estimated savings is around 27,440. And apart from that, it also shows the heat charge calendar heat map. So if there is a technical here, you can just see the surcharge as this area would be higher, and you can shift this surcharge to this 6 AM to 12 PM area. Now, coming to the consumer side this is the residential market system. Consists of the billing system and annual estimated system and total load. It also consists of count status like a peak risk, bill shock, and anomaly risk. Apart from that, there is an advanced disaggregation that is going on live in this and goes through tracking. So this you can see this is the goes through tracking that is constantly monitored in the system. And it also shows the appliance health and the upgrading intelligence over there. You can see it is consuming more than its length specs. If you update this, it will shift 10 to 15% of the energy. Apart from that, this also shows the time of use cost optimization, which is another key factor in this system. So now to the multi-analysis. This is particular analysis in the market. As of now, we have 5 means there in the market, and out of that, only 2 players not interested in monetization. You can see over here that the dimension is than any other system. Apart from that, the payback period of a system is much higher. If you see the competitive analysis for the discount, there are same players and still our system stands out in between of them due to having a less installation cost. Now coming to the total addressable market, India has installed over 3.46 crore smart meters so far under the national program. And another report shows that 47% smart meters installed across the India with around 3.3 million approved in total. The source over here is the economic time. So why this system clearly went up and graphs? You can see that in the system, simple system there is no feedback, and in our system there is total energy and appliance level feedback that we show. And the cost, switching cost is much higher, and this is the system that we use. So this was from my side, and I will try to answer any of my questions.
I think this is a good job. You have already two prices in the different competition. Why do you want to come here?
This is I'm still searching for any venture capitalist to present this project. Like we have also, yeah.
This is a good product you have already built and it is validated enough. Okay. Don't be in a hurry to sell yourself cheap. Okay, never do that. Never do that because you have done enough hard work. So try to connect to the energy companies and the state electricity board. I think that is your true track rather than going for a VC. You don't need extraordinary amount of money because you are not creating a device, you are practicing the electronics and your backend is long. So I think with that in place, I don't think so you need an extraordinary amount of money. So be careful, it's very clear and actually better on how to work on this, but don't, all my say is don't sell yourself cheap, never do that. Okay. Because you want some money for that, this is a good product, you please take this further.
Thank you.
So any quick reaction to what Ramji said?
Yes.
So anything, what roadblocks do you see for you guys?
So the limitation of our system is that you cannot predict exactly which device is there. Like if they are three in as you can see now, you can't predict that. It's our first roadblock, and second roadblock is still the noise in the bus that we are getting. So we are advising that we are not necessarily any pilot testing stages will be collected from the next requirements with an electricity department over there. So we still need to see if it works in the real time situations and how with our system by the electrical signal.
And what's the timeline for the residential unit testing in ISER? What is the timeline for you guys to test the residential unit pilot ISER?
It would be around 3 for this first pilot stage that we are trying to make it. Like we have 5 devices till now. So it would take some time for the data collection as well as the data manipulation that we need to do this system.
So, but you intend to get 60 devices up and running for ISER, right?
Yeah.
And how is that being funded?
No, we are not. Engineering department has been working on the system. Like the electrical engineering department has been working with private enterprises that are the basic company over there, as you can see. So we are trying to modify that system first into our system, and my software side is much better than the hardware side. So according to them,
Why do you say it's better? I mean, what most
in terms, so they are systems that are already the analysis systems. So they suggested me to work on the software side more than the hardware side.
All right. Okay. ISER. Depending on where the price is being done, so it's accurate that it will be as an ISER.
Sir, like your voice is cracking out.
That's fine.
Yeah.
Thank you very much.
Oh, thank you.
Thank you so much. Next, the team is from Dr. Ambedkar Law University.
The green IT is a very distinct going to present the topic, the AI-driven postal plastic-based detection system for sustainable management and circular system. So, what's the innovation is? First, the AI-driven and the AI-prone and the AI-camera is the plastic-based circulation system that implementation respect to the IoT based system. Then the solar powered cleanup device has cleaned the plastic waste accumulation in the coastal area. Then the AI plastic is recyclable in the recyclable groups like PET, PET, DFT, filtration. The centralized IoT dashboard is monitoring, analytics, and the trend tracking and decision making of the cleaning area. And how the innovation is connected with sustainable development goals is connected to SDGs 12, 13 and 14. Whenever one STC goes to be an achieved, the other 3 and 4 goals will be simultaneously achieved. And how is innovation related to the green technology? Not only is that innovation and the other countries really focusing their clean plastic in coastal area, in our innovation focusing their cleaner and plastic the group and making that roads to plastic road construction. The plastic road construction nearly duration period is easier, unlike other road construction is 5 to 6 years. Even the cost also in affordable price. It also helps to the R&D and how the innovations will be function in that, how the plastic accumulation will be being in the coastal area is also innovation. The EAD selection, automatic collection and smart segregation and circular recycling that. It also that integrating all process of one system. It is an innovation. It's also called as the novelty criteria. 2 plus J of the patenting act. The novelty and the inventive steps 2 plus J of patenting act. Also, it's all applicable to the industrial application 2 plus J of the patent act 1970. The hotspot area are spined out and the plastic easy and clearly. The content weight reduce and content weight and the recycling things happen to that. It's also feasibility. The issue and I put sensor and solar technology is feasibility. Even if no one we can buy that one. It also protects the international maritime system. The 80% of plastic accumulation is from the coastal and the river area. Whenever territorial natural plastic will be protected, the marine destroyed and the marine ecosystem also will be protected. It's also scalable. Even all devices, cameras or individual parts, we can easily dismantle and replace it to another coastal area. We can for government and industry foundations. The technological and the demonstration will be led by our teammate questions.
Hello everyone. Now I will do a demonstration video and simultaneously I will also explain the teaching method. Is screen sharing?
Yeah, what is saying? We can hear you.
Yeah. Now I will explain the technical aspect of technology that is the course of plastic waste management system. This can be economy inside the architecture, analysis, architecture, stock computing, and the innovation. Technology mainly focuses on 4 main areas, that is reduction of plastic area, communication between the interactive the collection of utilization of plastic, for monitoring and analysis. All together, these problems are going to be created and made, and it's a fully automated and intelligent waste management system.
I think this is why we understood the concept, what you are trying to do. Very well explained. I don't think so. We need more explanation. Just one question. How are you going to differentiate between the polymers? Is it accidentally differentiate the how is that possible? I'm asking you how your model will differentiate between different polymers. How PE, PP,
That PVC is a normal plastic which is used for soft drinks and water bottles. HDPE is strong plastic which is
how will you differentiate between those?
our artificial intelligence machine will be trained for executing all those patterns and based on convolutional neural
Okay, alright. I think that's
So
fine.
you just asked, are they using ADP as a solution?
Yeah, so you also have APP on this?
Yes, sir. We have CEP, the plastic which is executed based on AA and solar sustainability.
Thank you.
Convolutional neural network and
This is wonderful. The thing think I got all the answers. You have anything else to add? Last final.
Our innovation, our technology suggests that traditional waste management into intelligence automated and sustainable solution for the production management.
So you have a prototype or you are building one?
Yes, sir. If you give a permission, I will account the start the policy.
Please,
If you give me a permission, I will demonstrate the technology video, what we are going to do, what we are suggesting. Instead of explaining, it is more explanatory.
please do.
Okay.
Yeah, please. Simulation.
Okay, thank you so much, team. Now we will move ahead with the next team. The next team is from Panivala Engineering College, Chennai. We start the presentation.
Excuse me, Vaishnav, can you stop presenting your screen?
Now I call upon the next team from Panivala Engineering College, Chennai.
Yeah, I'm there.
Yes, please start.
So, a very good afternoon, good evening, respected leaders. Myself, Tanvi from Panivala Engineering College, Chennai. So, I will be presenting a project titled Breathe and Honest and Eco-Friendly Transit Solution. So, let me just dive into the problem straight. Waiting for bus stops around 15 to 20 minutes itself becomes the most hazardous place, and like 30 to 60%, and these are the data that I have collected. And for air pollution, vehicular emissions are being considered the second most source. And I'm sad to say that India ranks top 5 for being a most polluted country. And consistently, Delhi, Kolkata, Ghaziabad is also ranking at the top level for being the most polluted one. And at the same time, a lot of energy is being wasted on daily basis. Like you can see, typically talking about the bus stop, the energy is wasted around 2.5 to 4 million kilowatt hours per day. And here I am here going to address two major problems. One is air pollution and other is the unhealthy energy. So the major pollutants are being 2.5 million carbon monoxide, nitrogen dioxide, sulfur dioxide, and the volatile organic compounds. So here I have my solution for to address two major problems. There is, as I told you earlier, there is air pollution and unleft energy. So my project consists of dual energy sources. One is the solar panels, which will act as a primary source, and the second is vertical axis wind turbine. So moving forward, these energies are being activated and then stored efficiently in the lithium-ion storage, which works 24/7. And this is all about the energy, renewable energy management. Moving forward with air quality improvement. The air quality is being improved over there using two major steps like biofiltration and mechanical filtration. Biofiltration is all about the nature and mechanical involves major categories like free filter, HEPA, filter, and activated carbon. So all these workings are being controlled and monitored via the IoT monitoring system on the dashboard. So this air quality efficiency, this is the improvement of that. This being solved by this renewable energy resources. So let me dive into the renewable energy resource. As I told that solar panels are the primary one. Moving forward, the vertical axis is the secondary. So we know India being the most hot climate and here in the summer, it is able to generate about 4 crore tons per day. But in average, if I talk about the old years, we are able to generate around 3 to 4 kilowatt hours. Like I made latest capacity as 980 volt. So this can be considered as a solar primary source. And additionally, if any non-sunny days occur, we can make our direction to vertical axis. So whenever the vehicles pass by, it is able to, whenever it runs around, the energy is generated. So this is the architecture diagram where both the energies are being generated. So using the AC/DC rectifier, like both the energies are in different states. So in order to rectify it and store it in an efficient manner, we have used AC/DC rectifiers followed by the MPPT, that is maximum power point tracking. So I use the energy management for around 2 to 3 kilowatt of capacity, but I have told that it could able to generate 3 to 4. So the excess energy or surplus energy is being transferred to the municipal corporations or the grid electric management system, or else the battery is used to offer charging at their base. So this renewable energy system is being covered with the active and passive acidification. Biofiltration system, nature has given us tons of land in order to clear out the acidification like snake plant, money plant, and all that stuff. So we're talking about the mechanical acidification. First comes the filter. The 4 parts of the track and move forward the record texturing filter. Here the target is the are being targeted and then efficiently removed. And finally comes the activated carbon filter. So here the water organic compounds are being trapped. I know it's the understanding activated water organic compounds, but the efficiency is being 70 to 85% each, and the technical predictive is being given over here. So moving forward, the feasibility, technical feasibility, we all know solar panels, vertical axis are already add qualification and output. So this is highly feasible. And environmentally, it supports acidification, renewable energy is being generated. We do not need to depend upon grid electricity. And also, the commuter rails, that is the passenger to use public transport, will be and economical feasibility and initial movement will be high. Right now, the operation system will not be more high because it's completely dependent upon the renewable energy source. And I would also like to explain that smart bus stops was taken in only 4 destinations like Royal, Water, and Terrafood and Kalmata. It costed around 8.
Yeah, wonderful. I think we have all the things that is required. These data which are not giving required right now. Just want to know, is this in the conceptual stage or somebody is interested and already building anything?
Yes, I thought just create a small prototype.
Yeah, go to the prototype first.
Okay.
What are you doing? Are you talking?
You're on mute. We can't hear you. We can't hear you. Yes, now we are on.
So here comes the 6-watt solar panel and with a vertical axis wind turbines, which is powered by the motor for around 5 volts. Sorry, 5 volts. And then MQ7 sensor, which is used to monitor the carbon monoxide, which is used to sense it. And a DHT11 sensor for temperature. And MQ135, which is a sensor like able to calculate the smoke, that is vehicular emissions. PM2.5 sensor I have used, which is a major component for air pollution. And this is the digital monitor, that is the IoT display. In air purification, I have used a 5 volts DC brushless motor, where I have given the 2 filters, pre-filter and reservoir filters. So this is the battery which I have used for around 12 volts, which is connected parallelly. So whenever I just plug on this, I just plug it on, and whenever I just click on the system, this is the air quality is being monitored. The CHT11 sensor and all these sensors are working. It is this indication. And as of now, the results are being calculated. And the air is being also purified. Only when I am able to feel it. This was the old setup. The battery is used to store the energy from the solar panels and as well as the vertical axis wind turbines. So I have kept this model on the sunny days alignment terrace in order to charge it. So it is able to do based on this battery, and I will also use the IC regulator in order to step down the energy which will be able to cause air purifier and also the IoT display. So this was my previous.
Okay. Wonderful. Wonderful. Very good. No. Thank you.
And I would like to highlight that it also supports the SDG 7, 11, 13,
That's fine.
and times.
That's fine. Those things are okay. Thank you.
Thank you, sir.
All right. Thank you.
Thank you so much, Deep. Now we have Kanishka Singh from SMS Lucknow.
Next.
Good evening, respected judges, and I am Mr. Thakur, and today I will be presenting a solution to a problem that silently brings money and. Okay, sure. Okay, sure.
And also make only 3 before the list so that we don't spend time on other interactions. Start the presentation.
Please. There's a screen visible.
No, you are sharing only specific.
Is my screen visible?
No, you are only sharing a specific application. That's why you are seeing only your folders. Share the entire screen. Now I can see you, not the screen. Share the entire screen, not one application.
Share screen.
Don't panic.
Yeah. So it's a great idea.
No problem. No,
So now it is visible.
yes, very much visible.
Now my screen is visible.
Yes.
Yes.
Please start.
Okay. So many devices continue to consume electricity even when they are not actually used. In cases like hostels, PGs, hotels, offices, this is small waste multiplied with significant cost and environmental issues. To address this, I proposed an IoT-based system, smart energy management system that automatically detects idle devices and cuts off the unnecessary power. The system is built using a 3-layer architecture. The first layer is, in the first layer, IoT-enabled smart plugs are used to continuously monitor the real-time power consumption of each device. This means the system always knows how much electricity a device is using at any moment. In the second layer, a rule-based engine classifies devices as either active or idle. For example, if a device is consuming less than 5 watts for more than 20 minutes, it is considered as idle. Along with this, the system includes adaptive learning, which means it observes user behavior and improves its decision over time. The third layer, which is control layer. In the final layer, the system automatically cuts off the power to devices, which are identified as idle. However, to ensure safety and flexibility, users can manually override the system, and essential devices like refrigerators, Wi-Fi routers, set-top box are protected using a whitelist. This system can save money around 36 units of electricity per month per room, reducing 250 to 300 rupees in cost. At scale, this leads to significant environmental and economic benefits. This solution remains transforms energy management from passive monitoring to active control. Yes, sir.
So this data, what we are trying to explain is not required. That we understand. Can you just tell me how the system is understanding whether you are using the appliance or not? How is that?
Sorry, I didn't get the question.
You go back to the previous slide, please. So here you say whether your system is being used or not. How?
So no, it's not in use.
How do you know?
So it's not in use. It's not in use currently. Basically, the other devices already exist, but they have a main gap is that it is not autonomous and it doesn't read behavior of user behavior. So basically, my idea fills that gap.
Yes. How do we know that it is not being used?
Sir, IoT based system logic लगाएगा and then the data set that is based on
नहीं ऐसा लगाएगा क्या लगाएगा वो अभी मैंने कुछ कनेक्ट करके रखा है वो यूज हो रहा है नहीं यूज हो रहा है कैसा पता चलेगा
Sir, rule based technology is a local rule based technology.
Okay, I hear what you are saying but I don't understand. So that rule based means are you going to look at leakage current or are you going to look at the usage current? Are you going to speak something like that?
So sorry sir, the voice was
No, are you going to look at the leakage current or are you going to use the usage current?
So the phantom standby current basically it's the access current. We can say when devices are not
Yes. All right. So, only challenge here is you should know how much is the quantum. Quantifying the quantum
Yes, how much
of each device is not trivial.
Yes, so if we find the phantom energy per device,
Very good, very good.
980.
Just the fact that you understand that this is one of the major problems, I think you have found a very good problem. But solving that is still a challenge. Okay? Yeah. Do you have a prototype or do you have some concept?
So we are, no, so we are still working on it. We are still working on it.
Oh, please watch little more. This is really a good challenge. Okay, thank you.
Thank you.
Next, please.
We are extremely honored to have with us today Professor Praveen C. Ramakanti, Professor, Department of Materials Engineering, IISc Bangalore, as Dean Chief Guest, Mr. Sridhar Papisetti, Dean School of Government, MIT World Peace University, Architect of Honor, and Momo, President, Green Honor, Architect Honor. It is my distinct honor to introduce our Chief Guest, Professor Praveen C. Ramakanti. He is a distinguished academician from the Department of Materials Engineering at IISc Bangalore, and he holds an MSc in Polymer Science from the University of Mysore and a PhD in Textile Fibers and Polymer Science from Clemson University, USA. With extensive research contributions in materials science and engineering, he has established himself as a leading figure in the field, driving innovation at the intersection of materials and sustainability, and we are extremely honored to have him with us. Next is Mr. Sridhar Papisetti. He is a dynamic leader in innovation and governance. He has spent 2.5 decades shaping key institutions, including the Kothari School of Public Policy as its founding director and IIM Bangalore Center for Public Policy as its chief operating officer. Currently directing AI innovation at Grand Velocity.ai and serving the 1 Billion Life Foundation as a trustee, he combines technical rigor with management insight to solve complex local and global challenges. As sought after talent mentor and HPR published author, he remains a dedicated champion for tech-enabled citizen services and the power of youth-driven innovation and policy reforms. He teaches courses on public policy challenges for 21st century at IIM Indore and strategy management at IIFT Kakinada, amongst other leading academic institutions of India. He has also been an advisor to Government of Karnataka, much awarded Sakara programs, and continue to advise, consult, and mentor many government, civil society, and corporate endeavors. I would like to now introduce our next guest of honor, Ms. Momo. She is the president of UNAMO. She is a passionate advocate of sustainable living. Momo describes herself as a ragpicker by choice. With a background in sociology, development studies, and environmental ethos, she works closely at the grassroots to understand and address real-world environmental challenges. Raised in a deeply sustainability conscious environment, she believes that sustainability is not merely an agenda, but a way of life. To Green Namo, she continues her mission of environmental stewardship, driven by the belief that protecting our planet is both a moral and existential responsibility. We warmly welcome all our guests. Now, I would like to move on to the felicitation ceremony. As a token of I would like to request our President of ESA to kindly come forward and assist with the felicitation ceremony. I would like to invite Professor Praveen C. Ramamurthy, our esteemed chief guest, on the stage. Now, I would like to call upon Mr. Sridhar Pavisetti on the stage. And now I would like to invite Momo to the stage. I'd like to invite our chief guest, Professor Praveen C. Ramamurthy, to deliver the keynote address.
Okay, guys. I'm very loud. My wife never says that. Okay. Thank you for inviting me here. I'm really not sure what all of your background is, but what I will do is I will very quickly go through some work that we do. Only point I want to convey today is to make you appreciate how interdisciplinary any work is. Okay. So we work on organic electronics. What on earth is organic electronics? So we will come to that part as we go along. I'll think of a couple of different applications and then we'll take you the examples of it. I am from this place, right? MIT Meghalaya is a wonderful place. IISc Bangalore also is very nice. I invite all of you to. Right. Okay. Alright. So, as I was saying, IISc also is a very nice place, and I invite all of you to visit us. This is how it used to look 100 years ago. Right? Now it looks like this. None of these are Photoshop, so it is really nice. I'm just advertising for IISc for all of you to come and visit us. Scale. This is actual photos. None of these are colored. Okay. This is the group that does the work, and I come out here and talk about it. We work on all of this, right? So we make molecules, we make devices, we understand, try to connect these things. Again, as I said, all I want to do is to tell you how interdisciplinary it is. Right? You can't be anymore talking about I am from physics, chemistry, or mechanics, electrical, computers, not anymore. So that's what I want. This is what we do in our lab. Right? Just connecting. Connecting carbon and hydrogen and oxygen and things like that. Why we do this is basically band gap engineering. So we design a molecule, do lot of computational chemistry, make those molecules, lot of chemistry, understand electronic properties, that means physics, and make devices on that. And try to extract, use applications like IoTs and other things to do. This is what we do. That means on band gap engineering. Right? Again, you say I am mechanical, CS, what do I go for band gap? I'm sure you have done band gap in your 10th and 12th standards. Right? So this is what we do. While doing this, we make different devices. One of the devices is photovoltaic. So we make various different photovoltaic devices that works for almost long period of time. And this is data is actually old data, 50,000. Now we have crossed 100,000 hours. So that means real time. These are not accelerated aging. So that means 4 PhD students back to back have worked on this. Right? Almost 15 years data, and it works very well. This is what we do. Next, this is a very nice work that happened because I look at a lot of insects. And if you look at insects, you see many insects has compound eyes. Compound eyes means it has many small eyes. Why it should have? Have you ever asked? If you ask, you will know that many of these insects will be very active in a particular time of study. That means it tries to gather wavelength, electromagnetic wavelength in that time of time. Right? So it amplifies that. So some of them work in night, some of them in dawn, dusk, midday, any of these things. So we created some structures, put it on large area solar cells, and then try to extract maximum potential. So here now, if I had not looked at bio, I would not be able to use it as a field. That's your interdisciplinary part. Okay, as we move along, we do like a lot of reliability testment, do a lot of dashboard engineering. So reliability and dashboard, data analysis, data analytics will come into this. This is a nice thing that we do a lot of these devices for very harsh environment. What is the harsh environment? This is actually open challenge. Any of you have good, all of you have done some startups, some of you. Very nice things. If you want to test it in very harsh condition, there is an open challenge called IAEAT South. That is in Antarctica. If you want to send it to them, they will put it there and test. Actually, Robert Fon, we know him, and one of our colleagues went there. This is our device. We kept it there at ultra harsh condition, minus 80 degrees 0% humidity, ultra high UV index, and it still worked. Right? That was the idea. I'll not let this video completely tell you, but the idea is now look at this. Again, if I say I do only device and set it in the office, this is not that possible. Now you have demonstrated something at very harsh condition, and this is possible for many other applications that you are working on. Okay, so if I can make molecule that interacts specifically with solar light, I can make it interact with particular other electromagnetic wave. Specifically, this you have seen lot now, right? Last few months from both stealth, right? Stealth means what? You throw some radar, it doesn't come back. That means it observes and do what? Convert it as heat, then I can catch it. But if it converts as electron, I can take it up. That's how, if I throw at you something, nothing will come out. That is stealth. So we could do some molecule that can do this, right? I'll skip. I will not go through too much detail. Just show you some of this and then the next part is, if I can make this interact very specifically, electromagnetic or anything else, it becomes sensor. This smoke sensors you see, right? It's commercially successful all over the world, but it does not get only smoke. I take some chalk powder or I take this carpet and then do this. The dust goes inside and it changes the resistance and it gives out. So it's successful but not specific. Whereas in chemistry you can make it more specific. So we make various different sensors to detect various different analytes. And only pick up few and then we will discuss. So we do many of this. Right? You bring out any analyte, chemistry can make it to detect very accurate. Skip. Yeah, this is one problem, nitrate problem, where nitrate, whether from pesticides or from sewage, gets into water body and then there is a problem. How do we detect? Chemistry where there are many ways to detect, but can we skip? So can we do? So we do a lot of this computational simulation, make a device, something like this. This was some 15 years ago. Where you make this device, dip it in, like what you guys are doing now, like an Arduino device, dip it in, and then just measure change in resistance. And most cell phones has wonderful computational capability, you get that. So, as I said, this was 15 years ago. This is what look like, and then we'll skip all of the things, and it's very specific, only to nitrate compared to anything else, all those things. Blah blah blah. It's very repeatable. I can do it hundreds of times. All of those things. But this is how it is. Now you have our own electronics as big as a cell phone, pen drive. You go and like your blood glucose monitoring. You go measure it, take the data, and then the data can be uploaded to a dashboard. Right? This is like your Google map. So you can create a map of what pollution is there in which lake or which road. All of this can be done. So this is not for any one, so I can pick up as many sensors I want and put all of those append it to one to another, then I can create a wonderful map of it. Right? So here again you could see understanding of chemistry, doing some computational simulation, make the molecule, make a device, do IoT, electronics, cloud, everything else. And make a product also. Making a product is again not easy. You can do few demonstration by some Arduinos and things like that. But how do you make a product? Right? None of these are Arduinos. They have their own electronics. It has to be stable. That is a productization is what we need. Okay, next. This was a very interesting problem. This is actually came from RCD. RCD, you know, right? Trial challenges. They actually came and said sports persons drink lot of electrolyte during the when they are playing. Why? Because they do lot of electrolyte. Okay? Sodium and potassium. So how do we measure? If we don't measure, so you give them lot of electrolyte, they drink more, and kidney has to suffer. Right? If they don't drink, then dehydration. So how much to measure? How do you measure? You have to measure by sweat, blood, or urine. None of this possible when they are playing. So now we wearable device. So can we measure? Was the idea. So we looked at again biomimicry. Every one of us has in our body a protein that controls sodium and potassium. We design a molecule that imitates that molecule, right? And then we synthesize that. Now you understand how deep it has gone. Looking at a protein molecule, chemical structure, make a molecule, and understand its electronic property of a molecule that is in your body, right? Electronic property of that. And then make a device, very simple microfluidic like this, product design. Right? Again, please don't forget when you are in a startup, you are talking about. Always spend time on understanding the product. Oops. This is how it would look like, right? So a small band-aid kind of thing, where on this side you have a device and the other side is force, right? Do a lot of this and then the data says, pattern analysis, I can detect both sodium and potassium. Okay. So something like this, I can put a patch, somebody sitting here, a coach can sit here and then measure it, how much the sodium and potassium is for that particular player, and then player and RCT is all fun, but it is actually even more important in a medical terms, where especially heart patients and other various others, you measure electrolytes. And how you measure in hospital, you take a sample, urine sample, go give it to the lab, it will take almost 1 day before it comes back. But can we measure QCQ? So we actually tested in a catheter. This is a generic image, but then we actually inserted in a catheter, measured live, and it works very well. Right? So now again you see, if I say I don't want to touch a catheter to right, then we would be able to do a device. So again, trying to push my agenda that how interdisciplinary works. Okay, similar to magnesium, sodium hydroxide, we can detect magnesium. This is a magnesium response to everything else. Similar to this is zinc response to everything else. Right? So you can make, and this is all in testing blood, right? Like this wherever blood and sweat. So like this, your blood glucose monitoring. Now I can, these were all measured in the lab with huge spectrophotometers. Now I can measure it using just a simple solid state electronic device. Just by the way you measure blood glucose, I can measure all. Right? That's where the whole technology is moving towards. Where it is such interdisciplinary, you need to understand all of this together. Okay, next another problem. I think only some ladies will understand. They have problem with thyroxine. Many ladies will take thyroxine, levothyroxine medicine, but it controls thyroxine, but it affects various other functionalities, and they suffer, and they can't help. And my wife keeps complaining, you don't understand. It is true, and I am just joking, but that is a universal truth. People other gender won't understand what they is going to do, right? So, how do you detect? Very difficult. You have to take a sample, blood sample, go measure, that you do once in a year. So again, the thought process was, can you detect like the way you do that glucose? With that, again, we did a lot of biomimicry. We measured, we were able to measure as low as 0.01 micromolar, medically relevant. So again, this is not a device that I can sell tomorrow, but the idea is there is a concept that I can do with this. Okay? That's the idea. Last two, and then I will stop. E. coli. I don't know how many of you know E. coli. I don't know what an E. coli is. I am not a biologist. But I know E. coli. I don't want E. coli whatever I eat because it's a very bad. Okay? Only certain strands of E. coli. You will be surprised. Please go to Google or ChatGPT. How many fatalities happen by E. coli? Quite a lot, more than snake bites. Okay, so I don't know what an E. coli is, but if I go look at again the protein part of it, certain lipids, certain proteins are very predominant in a particular E. coli. When I say it is predominant, all I have to do is chemistry and look at the chemistry of this, make a molecule that interacts with specifically, make a device like this. Right now, if I want to measure E. coli poisoning, I have to take the sample, put it there, give some food to that, wait for 48 hours before it grows, look through microscope, culture it, look through microscope and say how many are there. By the time patient will die. So we can detect immediately. This is one of that where we can detect 1 CFQ parameter, means colony forming units in real time. This is seconds. Immediately, within few fraction of a second, that interaction happens. You can see the color HCM where E. coli gets absorbed electrostatically. Again, if I say E. coli, I don't know, device I don't know, a polymer molecule I don't know, but the electronics to pick up that I don't know, it will not work. You need to understand, at least exposed to different areas of everything else in that. Okay. Last but one is microplastic. We have been talking for a while. Actually, microplastic has been found in placenta. Placenta is where the tube connecting to mother and the child. The fluid that is there, that has microplastic. Right? And nobody cares. As they say, nobody cares, nobody bothers. But that is a major challenge, and also, of course, insult to humanity, the way we are going towards. But then, how do we detect? You can't detect. It's very difficult. So, result can we do? We actually did not going to science, but then if we do, we make some biopolymer that behaves like polystyrene, not all microplastic, one polymer at a time. You can see the response to polystyrene compared to everything else is different. So that means I take this device, put it there, I can tell you whether that water contains polystyrene or not. Again, it is not a commercial device yet, but a niche idea and a demonstration that it can be done. Again, students made a filter with ChatGPT generated image, but then the idea is, look, I can make a filter. If you give me this, a filter polystyrene that is there. That is wonderful. Last one is urea adaptation in milk is very, very high. Okay. A lot of government run dairies are actually good. Many of others are not good. So why do you adulterate milk? How do you buy milk? Milk you buy basically how much is the density. Right? So what you do is you put a bead, you see where it stops, and then based on that there is a calculation I give. I make it, I want to make a larger quantity. What I do? I put water. But water decreases the density. What do? I take some oil and then put oil. But oil is not good, it doesn't disperse. What is a good dispersant? Is urea. Urea is very good. What is called emulsifier. It catches onto the oil, it catches onto the water, so that means it distributes. And you get a good milk. That's how you do it. Major challenge, and nobody bothers, right? And we feed to kids. Anyway, so we made molecules, again, not going into chemistry and physics of it, make molecules, make devices. We can measure urea compared to anything else that is there in milk as low as 1.5 micromolar, very small quantity we can measure. Again, here you need to understand what all angles came in to achieve this what is possible. Okay. So basically, what I want to show you, this is figuratively chemistry. You can do any analyte you bring in because every reaction or interaction is all electronic, right? When I say I'm touching this, what are you really touching? What is touching? The electrons. Outermost shell on this is touching your electron on the outer pressure. There is nothing else that is touching. So its interaction is electronic. So if I can do electronic, I can measure everything. That's the bottom line of it. So for example, here copper, lead, iron, chromium, chloride. You tell what is from. I was asking somebody what's the challenge in water in MIT Meghalaya. Somebody was telling fluoride. So you can provide, and you guys should explore whether you are from electrical engineering or civil, we should look at this. Okay, so as I told you, we incubated a company, not a good businessman, but then we made a device as small as a pen drive now, like your blood glucose monitoring. We make these devices, and go measure. Anybody will get the data there, and also it goes to a cloud. So you can create dashboards and dashboards of things for various applications. So that is the idea. This some time ago, but this is where we are. I think with that I'll stop. No, one more. Yeah, this is one thing I want. Very funny. This lady, she is in New Zealand too. She works on. She's a biochemist. She works on energy. You know how when elephants eat, you know biochemical electrochem is basically need acid, right? To convert, to push an electron out to a different metals, and then that's what your cell is. So when elephants eat leaves or grass, its acidity level in the dung is different. So she measures that. So she is working in energy field. Right? She works in a so this is just to tie up and say, don't ever limit yourself saying, I'm studying this, so I only have to go to this area. No, you can connect to whatever you want to, the limitation was, right? Study the without anything, I stop. I want to graduate. Anybody is interested in any of the things which I talk or any of your challenges which you are going through or you are starting other projects, I am always there to connect with me, easy to connect to me. Thank you.
Thank you so much, sir, for your valuable presentation. Next, I would like to call upon our distinguished guest of honor, Mr. Sridhar Kamisetti, to deliver his keynote address.
All right, let's get started. Good evening. Appreciate your patience for waiting for this talk. I think when you look at big innovation, it's quite a crazy challenge. Right? And no matter what you ask, the jury will always ask you something more than what you thought. And I just try to give you some ideas that you can think about as you go through your journey of building an ecosystem to make your innovations successful. So what I'm going to talk about is how we go from problems to possibility, and building a generation of big innovators will need you to build certain capabilities. My name is Professor Sridhar Bhavishetty. I teach public policy, governance, systems thinking at various institutions. But right now I'm involved in an AI company called Nanotech Security, and then look at how you look at branding and marketing to be change through the world of AI. As all big innovators, we are all challenged with one thing: how do you deal with trade-offs? Right? There are multiple trade-offs, not just one. There is only one trade-off that is simple. Right? The first trade-off is growth versus environment. Right? Oh, I innovated and got something, and I want to grow, but there is so much impact on the environment. I don't know how to balance the right? Do I grow slower or do I grow faster? What are the ways in which I can reduce my impact on the world? The second one, jobs versus just transitions. Right? I mean, a whole lot of industries are reimagining how they are going to work in the low carbon. And when that is happening, many jobs are at risk. Right? So how do you balance the human aspect of keeping people employed versus doing climate justice? Right? So this is the second trade-off. The third trade-off is convenience today versus climate stability tomorrow. Right? Of course, I want our children to have a better tomorrow, but should I sacrifice my convenience today? For some, it's easy to answer that. For some, it's not easy to answer. So these are the three challenges that we all are suffering with. Right? So as green innovators, we have to find solutions that answers all these three challenges. Right? So we have to do all of them. Now, what's a simple idea? Right? Let's start kind of converging on looking at it in a very simple challenge. Every unsolved problem you see around you is an unbuilt institution or an unbuilt innovation. Right? There are problems around us. It just needs an institutional response to it. It also needs an innovative response. Right? We need to do these two things. If you are sitting flat every monsoon, this is a sign of an unbuilt climate resilient infrastructure, right? And it's also unbuilt data system. Places around the world which get flooded, but we really don't know what to do about it. Right? So that's a capability that we need. Next is, if waste piles up around your campus, then there is a sign of unbuilt circular business models and unbuilt accountability. You can't just say that, oh, you know what, some people are responsible. You need to kind of set accountability to different players in the ecosystem. Right? So how do you go around building this accountability mechanism and not just think that naming and shaming somebody will be the enough solution to bring about change? The third is, if farmers are struggling with unstable rainfall, that is a sign of unbuilt regenerative agriculture ecosystem and unbuilt risk sharing. So we need to figure out and say, yes, if agriculture fails because of climate change, all of us are going to be affected. How do you build mechanisms so that we all can agree together? So what should you do? A good, simple idea, but what are we going to do? So if you think you are here to build just apps, devices, or business plans, that's not it. Right? You need to think what is it that is survive and make you successful beyond all these things. Phase 1, great device, everybody claps. Phase 2, great app, everybody claps. Phase 3, all the business plan. Phase 7, area, it will problem solving. Right? So what do you need to do? You are here to build those missing institutions and innovations. Right? On a small prototype scale, you can begin with that. That's how all innovation has started. But with the ambition that they can grow and influence policy, markets, and mindsets. Right?
I think in one of the presenter presented some interesting innovation. The jury's response was, when you are ready with the solution, come to us, we will put you to the right place in the Ministry of Environment. Right? You need to kind of go to that level of leap where a ministry can appreciate what you have done and say yes. Right? It's not going to say yes if you have done only the first thing. You build a lovely app, you build a great device, and you build a great business model, business plan. That's not what the ministry is looking at. Can you think like what the ministry wants? And that's when your innovation will be embraced. Finally, I mean, we are in the lovely Himalayan region. We are in Meghalaya, and this is something that we always see. Take only memories and leave only footprints. Right? So, anytime when you are innovating, right, always go back and think, well, in the name of innovation, am I postponing am I creating trouble for the future? Right? So this is something that we should always keep in mind and say, can you think simple? Last evening, we went late for dinner to find dinner around this place. We did not find dinner for quite some time. We went around and at 10:30 we found somebody who made amazing momos. And it was street side stall, but we were also getting tired. So we said, can you parcel and give it to us? So he practically gave it to us, and I came back to my place where we were staying. And I opened it. It was such a lovely packaging. It was a large leaf in which he had packed everything. And the aroma was still there fresh. He had put coriander on top of it, he had put onions on top of it. And when I ate, I could see the benefit of it. In the name of innovation, if I try to do the same thing in Bangalore, where I come from, 90% of the time it would be in a flat plastic box that comes. It's not as if there are not enough leaves in Bangalore. There is no mindset to change. So now, how do you think? What is the structured framework for you to think that's the solution? This is something that I want to give you. This is a lovely butterfly model, and this is something that all my students invite as they go through innovation cycles. You look at the renewable cycle on the left hand side. You look at the finite elements on the right hand side. Okay. What do you mean by renewables? What do you mean by renewables? It's available again and again, right? It never goes out of it, right? But some are only finite. There is only limited supply of a few things. What is limited supply of a few things? Coal, petrol, natural gas, right? Sometimes, if you don't think through, even your metals, if you end up using them once and throwing somewhere in unrecoverable fashion, then they are also not renewable in that sense. So what do you see here? You see here on the renewable and the biological cycle predominantly, you can go to the path of biochemical extraction, anaerobic digestion and biomass. Right? Then you can look at a regenerative route, and you should look at wherever you can catch hold of the renewables, grab them, fix them. But what happens with finite materials then? Right? You need to think, whenever I make innovation, take catch it, but is it meeting the circular test? How do you do that? The first is the sharing economy. Right? Everybody need not buy a car to travel in the city. Right? You want mobility, you don't want car ownership. What do we all of us want when we want to go from one place to another place? We want a car, a bike, a plane, or we just want the mobility, right? So that's where all your Uber, Ola, all of them have come and created ride-sharing platforms. Right? Now, can your innovation be shared amongst a lot more people than just one user? That way, your footprint reduces because more number of users are using the same device. The second thing, right? Do you have inbuilt maintain and prolong cycles in your design? Right? It's I hate to say this example, but this is what kind of worries me a lot. The most innovative mobile company in the world, right, had planned obsolescence in its devices. Right? This is where I find that the best brains are not necessarily doing the best things. Right? If a new version of the phone was being released, then the company could trigger the batteries to slow down on 2 versions prior. This was caught, and EU fined this company. Right? So why are the best minds in the world solving the best problems? So you need to be very mindful of this. Today, many devices are not repairable. Right? If you don't have this conversation with your parents and grandparents, they will always say that anything can be repaired and reused. But for us, we have an end of life every device, every few years or every few months. Right? So the prolonged maintenance is very, very essential. Right? How many of us use refrigerators? All of us, right? Most of us. Right? And in refrigerators, any rocket science that has changed so much in the last few years? No, right? More or less, ever since the set of the CFC versions of the refrigerators, they've been more or less being the same. But today, go back and see, are the new refrigerators that are coming into the market, are they maintainable beyond a 5 years, 7 years cycle? No. They say, sir, discounting. So why are we not putting the maintainability and prolonging the life of our device? Right? So this is something that we have to embrace as a general. Can you reuse and redistribute? Can you then finally get into refurbish and remanufacture? Right? Today there are players in the world where your laptop will never go out of usage. You can do a memory upgrade, you can do a hard disk upgrade, you can do a processing power upgrade, because these designers are saying, fundamentally questioning, saying that I don't need to con my buyers into buying a new laptop every few years. I'll keep the shell the same. I'll make sure that as many elements of this can be reusable as long as possible. There's definitely reusable on your mobile phone as well. Right? Every few years we need not buy a new mobile phone. If you want to swap out and put a new camera, you should be able to do it. If you want to swap out and change your battery, you should be able to do it. Do you buy a remote every few years? No, right? You just change the cell. Think about your devices being such expensive, such refurbishment, such remanufactured. Right? Today, out of any manufacturing company, you only see finished goods going out. But why aren't they accepting goods they sold 5-10 years ago and saying that I will recover as much and push it back to an next product? Because the design mindset has been lost. Right? So, for the big innovators of the future, if you can't be circular, then the chances of your success is going to be low. With this, I would like to stop my presentation. Thank you so much for listening and see you all.
Thank you so for your interest. We have really learned a lot, and thank you so much for being here at NITM. Next, I would welcome Mrs. Momo, the founder president of Green Ammo, which is one of the most unique startups we have ever about. Thank you.
Good evening, everybody. First of all, thank you so much for holding on to your patience because it's been a long day. For us, it's been now for you to begin with the entire program and it's been running for about 3 days. So congratulations on that. To our patience itself is very big credit. Now, my name is Momo and you can address me as the same. I do not use a surname and that is my identity. And as this beautiful little child has explained that I am the co-founder and the mother of the trust. It is called Green Ammo. Now, what Green Ammo is, I believe there will be some slide that will be running, and you can use it as a movie and you can just keep checking because that shows the work that Green Ammo has been doing. If there is any question with regards to that, at the end of my talking and blabbering, I'll give you an opportunity. You can always ask a question with regards to it. What I want to address today is not about what I do or what my organization does. I would want you to get into one little practice where you will not consider yourself to be people from the engineering department or from the technical side or from IT or from innovation in general. Can you please, now till the time I talk, consider yourself to be resource-consuming human beings? Can you do that for me, please? Because unless you do that, whatever I say is going to be futile. Can you do that? Great. I have a simple question to ask. How many of you have crossed a landfill? Yes. Lovely. So have I. How many of you have stood in front of the landfill? Lovely. How many of you have entered the landfill, done a study? Does it mean that I'm demeaning people who have not? No. What I am trying to suggest out here is you need to understand waste if you want to even touch the idea of sustainability. Now, why does landfill matter so much out here? Because landfill is the mirror of the waste that you all out here with big shots innovation today are even thinking of developing, and the very waste that you produce in your own house as resource consumers. So it is very important for you to also be human beings while being innovators, to be able to understand what sustainability is. Because today, while I was listening to all of you, and this is not to make you uncomfortable, you know what, it is to make you uncomfortable because it is discomfort where understanding of reality is. Today when I was listening, there was an aspect of innovation, there was an aspect of technology, and there were words of sustainability. But somewhere down the line, there was this big gap that sustainability has two versions, right? There is an environmental sustainability, there is also a social sustainability. When will there be enough innovation that can be in the doors of a hut that does not have doors? We now work in places where there is no house, there is no roof, there is no toilets. You talk about smart cities, you talk about smart phones, you talk about smart things. I am talking about villages where there is no toilet for women, leave aside electricity. So are you systematically telling me that they do not deserve technology? They do not deserve innovation at all? Is this the definition that we want to today create of green innovation? You need to come out of the comfort zone of this notion that you have, a predisposed notion that, oh, there will be electricity, oh, there is already a road, oh, there is already a bus stand, oh, there is already half the system in place and we are going to improve all that with an innovation. All of that, great, important. I am talking from the perspective of the grassroots. I'm talking from the humanitarian perspective. I'm talking about areas where there is no hope. I am talking about places where need smart bins, they still do not have the time or the lavishness to sit and think about where is this plastic going. Because there is a problem of something called not enough food in the stomach. Now you might be asking me, what is this entire dialogue? What is the purpose of this entire dialogue in NIT? Why am I talking about it here? I'm talking about it here is because there's a big technology gap in technology for the elite creamy layer of society and technology for those who do not even understand the meaning of technology. That is where I expect the younger minds to get down to. Because unless you do that, your technology is also included to most of the fancy things like bamboo toothbrushes, bamboo bottles, bamboo comb. How many of the bamboo toothbrushes have you seen being used in the remotest of villages? How do they use it? It's 110 rupees. Do you know what 110 rupees means to a person whose entire monthly income is 1,000 rupees? If your technology is not brought down to a level where village to village, individual to individual, government to government, panchayat to panchayat, block to block can use, then your technology sounds very only at our government level. What is the use of that technology? We still have 30% of the population who struggle with very basic necessities. We cannot have a non-inclusive reinvention. Try to make it all inclusive. Try to start considering out of 17, 18, 20, 50, 60 papers when you get as abstracts. Try to see if there are at least 2 papers that is systematically targeting those layers of the societies who do not get anything. I work with practicals. I am one myself, I work with practicals. I work with very those people whom none of you would be comfortable sitting and sharing a meal with. Then we need to consider and ask ourselves, how dare we call ourselves innovators when we cannot even call ourselves human beings with the concept of equality in existence. I work with my brothers and sisters and we work with a very simple concept. Wait, what are you telling me? This is something I work with the concept of water break. You cannot call it technology or innovation. It is a simple thing where you have all of these drinking water bottles and there's a plastic which manually soft plastic waste, chips, chocolate, Maggi, rubber, mini, all of that gets into the plastic bottle using a regular stick. You tighten it, you reach to a particular level of density and ensuring that there is no space inside. These water bricks can be used as non-load bearing sustainable construction raw material. What is non-load bearing? The wall between the 2 pillars and in between you have a wall segment where the bricks are used. You can use these water bricks there. Right? Why do I work with this? Why am I not working with something which is related to technology, something which is related to innovation, something which speeds this process up, where in a single day I can probably make 20 lakhs of these water bricks. You know why? Because I work in areas where there is no electricity. What machine will run? At least the targets that I'm having, there is no electricity. To assume that there are already established systems in place is the very gap that we are now having, right? So again, my plea to you all is the idea is not the issue, technology is not the issue. These are great things, but are they inclusive? Are they technology right enough, or do we need to redefine the idea of technology altogether? Because real world problems, they are a little messy, they are inconsistent, they are slightly unreasonable as well. And there is a very big challenge that we have. This diaspora of people that I'm talking about, they have already come up with their sense of innovation. You know what is their sense of innovation? Let us burn the waste. According to them, that is the innovation. Let us burn the waste, let us dump the waste. What is their innovation? Why do they burn it? Why do they dump it? Why do they consistently bring that very bad air. Because all of the technologies probably have not reached up to them, or they do not understand the technology, or the government is not just interested to get that technology there. Right? And they have the incorrect idea in their head that, oh, previously we could just collect it in one place, now it is just burn it. I don't see it anymore. We need to start considering these micro factors out here. Right? I do not want to increase on the gray area too much, but this is also a very reality check that I want to give. Today's topic is innovation and sustainability. Am I correct? Am I getting it right? There is an aspect of sustainability. You have people you all out here who have been working with sustainability. Was it necessary to have basketball goals? I'm asking a question. Yes or no? Was it necessary? Could you not have the steel dust, or what is so bad about steel dust? We talk about innovation of big things. We've tapped these sources of lightning and convert that into electricity. Convert habits first, no please. Please convert the habits first. And you know why we have never thought about it? Because it is not a priority at all. We are so hell-bent on big terminologies and big actions and big projects that we forget that all of it begins at the personal level also. This was not necessary at all. A sugar packet was not necessary at all. Normal sugar just works. You are the generation that believes in making everything food. Can you not make steel glasses food? Or are you that handicapped with the idea of marketing and with the idea of modern day? Was it necessary to have all of the plastic packaging for all of these very trophies that you're giving us? Can you not say no to the plastic packaging where it is possible? Before getting into technology, get into changing the perspective first. Is this an insult to you? No. It is something that I'm trying to bring into perspective, but this is the problem. We have become so deaf to changing our own mindset and perspective that unless a hard-hitting statement comes, it feels like a layman discourse that is not important at all. So all I'm saying is, when arrangements as such happens, make it so visibly sustainable that I do not need to question. Make it a living proof that you are believers of green innovation in your action before you get me a prototype out there. All of these, where is it going to land up? Please tell me, where is this going to land up? Give me an answer, where is it going to land up? All of the report, that just impressed me, and as an individual, I'm indebted. I really am. But where is all of this going to land up? That very landfill that you all have crossed, but you've never entered and done an inspection on. So I come back to circle one. What we do, the website is there, www.greenammo.in. There's an Instagram, green_ammo. There is my personal number. You can always get it from the organizers. You can get in touch and you can discuss it at length. But please try to bring technology here first, in action first. You cannot be green innovators if you do not think green, right? I do not know about you all, and I keep saying this. I don't have a second planet. You might, I don't. I have only one planet, and I do not believe in a second life, so I have only one life. And I am going to work towards it. And I am not going to bend down to the idea that you can survive being a green thinker, being a green entrepreneur, only if you work for that layer of the society that already has a lot of things. So next time when I'm here, I hope that there is something that starts with the basket and goes at a micro basket. Thank you so much. Yes, sir. Yes, sir.
I thought you had worked only in Meghalaya and Himachal. I saw Goa, West Bengal.
Yes, so safety is West Bengal. Safety is in West Bengal.
Goa also.
Yes, few other places. So Goa, we were doing in Goa, Anjuna. So we were doing a beach cleanup, segregated beach cleanup of getting into touch with all. There is a huge SHU in this was might know there as well. And there when we started working, this is quite some time back, we had a very interesting person out there who wanted to have build a prototype, but the container of engineer did not find plastic waste management important. So he took it up within his own compound to build an open path. This is in town, this is the Meghalaya, this is the museum. This is the Bottom Museum, this is in safety, this is a playroom, Anganwadi. This is an Anganwadi, this is in Manali itself, it's in a project space. This is the toilet, it's in a water place. Now, all the water structures that is made for the community is completely clustered. Only the prototypes which is there in our area, we keep it exposed for a couple of years for people to actually understand the design and thereby cover it. Because we have to work with the various units directly their plastic bottles. So we have to completely cluster it. But yes, and these are sterilization units for our porta for the street dogs. So why do we do something for our own species, which we are very good at, all innovation, all technology, everything. Everything is always for our own species, and we do not need other species at all. So let us start with at least that species that we have systematically managed to make half human and completely dependent on us, and that is dog. And today when there are too much a number, we have a problem of stray dogs. Why did we start taking them? Why did we convert them into wolves? You needed them, no? Now they are in the environment and you cannot tackle them anymore. So the least of the things that we can do is sterilize them in a humane manner instead of bundling them up and throwing them in the forest, which happens a lot in Meghalaya as well, or bundling them up and throwing them in the riverside, which happens a lot in places like Himachal. Before you start loving anything, be that technology, further features, this and that, try to think if you are good enough to handle the end of it as well. So we work in small restaurants as well. This is a very important thing that we work with, and this is for 1, 2, 3. I see 3 women, and I would end up, for 1, 2, 3, 4, yes, and myself 1. At least gender-wise, I identify myself as a woman, sex-wise, I'm a female, so I am a menstruating person myself. Without white. Head down. Yes, can I please get your attention? Yes. Just give me 2 minutes of your life, I'll be indebted. If not, then staying here and not listening is one thing. If you're not interested, door is right here. Right? Because this is for the goal. Now, I would want to ask one thing. What do you use when you are on your periods? Menstrual? I couldn't do it, I'm so sorry. Okay, great. So a few will use sanitary napkins. Yeah? So if you have done your research, a single woman is responsible for sending at least 10,000 sanitary napkins into the landfill, burning it or dumping it. And this is only the sanitary napkins. I'm not talking about the single plastic packaging, and I'm not talking about the large plastic packaging. We are single-handedly responsible for a huge section in the landfill. I am not going to stand up and give you a lecture on what menstrual product you should use because it's your body, your interest, and your right. What I would urge you to do is try doing a little research on the innovative alternative products. That could be menstrual cups, that could be period panties, not tampons. That is not good for the health. Just do a little research on that. And if you're averse to doing research, we need to reconsider our presence in this planet a little bit. If we are not even ready to do a research because we think A, it is a taboo, B, why? And C, I urge all the males to also start asking the females because I realize you do not have a uterus and you do not have a periods, but your mother, sister, girlfriends, aunts, they have. And second of all of that landfill and the leaching, the soil you're using as well. All of the burning the air, you're breathing that as well. So you have absolute right to talk about menstrual waste. Get out of the taboo that only people can talk about menstruation. The output and the waste of it, you have absolute right to talk about it. So talk about it. And if you just do a little research, the internet gives you a lot of information. You don't have to depend on me for it. Thank you so much.
Thank you, ma'am, for your address. And I think 2 minutes. I as a head of ECEL and Meghalaya, ma'am, I agree that, ma'am, like we got that plastic bottles and I think the basic reason is that now it has become so convenient that it's become a part of our lives. And that's the reason I think so that we don't realize it.
Exactly. You are not the fault. It is a fact that you're so comfortable with it because it's
Yes, sir. Yes, sir. So, I think so now everything is like even not only I have seen videos like you can see plastic bottles are really the banana trench and serves talking about the placenta. It's like it is very unconventional and that is why we have to make that change. And today I know the biggest reason for this is that it's cheap and it's available to everyone. And that's why people will prefer it. But as a head of organization, today I want to take one decision that first of all I would like to connect with ma'am that today whatever you're seeing from the decoration to the decor, what can be changed in a green perspective? And from now, it might be more expensive on the budget end, but the east of connecting Meghalaya, we'll be moving towards a total green approach. From now, we're only using biodegradable and other products, and we'll be ensuring that how much we can do, we'll be making it green. And today is a very good day, so let's be not only in Meghalaya, he said, I would also like all the other student bodies also to implement green and sustainability. But I think so, this change will take us some time, and ma'am, I want your help and support in this process. And from now onwards, we'll be we'll also be going towards green and sustainable development, and from next time, no plastic products. So now we will resume with our remaining participants. Now I would like Mr. Aditya from Deshbandhu College to continue with the final three presentations we have for today. Thank you.
Hello, Aditya, kindly unmute your mic. Aditya, kindly unmute your mic.
We will move on to the next presentation by Pranjal Dey from NIT Rourkela.
we can't hear you. Are you presenting by your phone or? Yeah, maybe relog in. What they say, maybe go to the next one. We can see you, but can't hear you. Yeah, please, start.
Good afternoon, respected students. I am Ashwin Vikas, presenting you from the National College of Education. Our project is which is built on optimal core the evidences are rights, no sector. Economy. We are getting high and tech private. So, we do this by segment. From environmental challenge. Now, it's the real problem that we are facing. The real problem is that the agriculture is consuming 70% of the global fresh water, and yet economically it is low return on this. And soil, and with the use of the fertilizer and the emerging of the green revolution, there is a constant degradation in the soil. The most important, our youth are depending on the farm. So this is not just an environmental issue, but this is an economic collapse of the rural youth. Our current, even though we see the current solution, we try to optimize the state programs, but we do not. We replace the dependency on nature to control the season system. And here the project relatively is the systems architecture. At the core of our system, that is enabled by the advanced air control microclimate architecture. And if you go, how does it function? It will the sensor will track the carbon dioxide, humidity, temperature, and the light. And the data is processed locally using the HDR, not the cloud, because it allows real-time response. It works even without internet, and it reduces latency to near zero. The system instantly adjusts when lightning and humidity. I wanted to highlight that you covered the aspect, which is the filter, which is approved by the US Energy Department. And the entire, and then you can take the office as a self-correcting ecosystem. And this entire system is how inside the modular data channel. That is, which can be used by any urban hospitals. So it becomes our working principle. That is based on the electronic form. In electronic form, the representative is a very fine directly to plant. We use the control keys, that is programmable logic controller. While this will lead to a maximum nutrition absorption, minimal resources wastage, zero soil degradation, and this water is recycled for source use. No chemical runoff, no groundwater consumption. So
Can you hear me? What you wanted to convey? You basically saying the use aeroponics. Where are you at this? People do use aeroponic quite a bit already. So what is the difference you are bringing?
So, bringing the aeroponic farming, we can we have a less dependence on the soil. We have a more
Hello, listen, please. So that part we all know. What is the new thing that you are bringing here?
So by introducing the aeroponic farm, we can introduce many unemployed graduates from the arts, or the commerce, or from the factory technology.
All right. Okay. So you have answered. You have answered. Thank you. I have no other question. Thank you. Thank you for waiting so long in the evening to complete your presentation.
Thank you, sir, for the opportunity.
Of course.
Thank you very much, Aditya. Now we will proceed with Pranjal Dey from NIT Organic.
Pranjal, can you hear us?
Yes.
Yes, please.
Hello.
Yeah,
I am Pranjal from NIT Organic, and I am going to present my solution on circular.
What happened suddenly?
I hope my screen is visible.
Yes, it is visible.
So this is the prototype I built for the circular economy platform. As we know, all the waste and materials are thrown in without being recycled or sold out or being used once again. So I have made this all-in-one intelligence platform. So basically, we would input our waste needs and run AI classification over here. It would basically classify the waste into electronics or into or as the AI fits. So if I write over here electronics and the quantity is suppose 2 kg. So I have a e-waste over here. So if I run the AI classification, I will just show you this is actually electronics based on one. It's actually electronics based. So as you can see in the solutions panel, the AI had detected electronic as the class, and this is a probability that this is the correct one, and it's showing the expected price. What is the recommended pathway it is suggesting, and what are the relevant actions it is suggesting? So we have not only built the dashboard tool for AI for running the AI classification, we have also built the marketplace. So this is the marketplace where there are buyers, recyclers, and sellers. So basically, you can connect to industries, any metal for any electronics, for any selling electronics, steel scraps, and organic waste. You can so these are the things. So now I have to sign in. So if I create an account, so I can give my profile type as seller or buyer. So if I give it as a buyer, so I can after creating the account, I can go to the marketplace, and this is the nearby recyclers map and marketplace listings. These are some like a demo part. So this is a buyer demand map. So basically here we can what we want to actually buy. We can post a demand over it. So if I have a e-waste, so I can demand the quantity over here. Suppose it's 20 kg, and at what amount we are buying, suppose 5 rupees per piece. So and we can write the location over here and post our demand. So here both the sellers and the buyers will be able to do it by signing sign up. It create another account.
No, understand. I think this is very good, very nice idea. Between one. Only thing is, you need to make the user to fill this and the end user to get involved in that. I think that is the bigger challenge. Otherwise, this problem which you have identified and the solution you are giving is definitely common. There is no question about it. Okay.
Just curious about how did you build this database and how do you intend to keep it current and how do you intend to validate all the existing details?
Sir, you also like validating, right?
Yeah. The market.
So validating.
The marketplace.
Like you're validating the transactions.
No, the marketplace information. The listed buyer.
Sir, I think you mean like how do we, so this is like just a like.
So, how
you're not implemented in this solution, you can ask for any proof or anything like that for buyer or stuff.
I understand what I'm saying is, how do you know how much better recycling industries is compared to benchmarks and metals? And how do you improve the accuracy of your documentation?
Like the accuracy of the AI.
The accuracy of the listing of the marketplace players.
So accuracy of the transaction.
Go to the marketplace. Go to the marketplace.
Yes, yes.
This is a bunch of buyers, right?
Yes.
How well do you know each of these buyers?
Like you are telling, like how can we trust these buyers?
How, on what basis are you recommending these buyers to me?
Okay, so basically I am recommending these. So as you can see, it's like just a model type of thing. So we are basically recommending it on the basis of like ratings. On the basis of ratings, we will have a rating system, and we will also have a separate like a leaderboard system.
Okay, thank you.
So just one thing. So I have also a waste assistant feature for chatbot for asking anything about all the waste ones.
Okay, I think that's it. We are done with that. What's the next plan?
So the next plan is to like basically to partner with the industries and find nearby recyclers.
Yeah, that's easier said than done. I really wish that we will take that up. Okay. Thank you.
Thank you so much. Now the next team is from NIT Meghalaya and it's Legon Saitya.
My screen is visible for everyone?
Yes.
Okay, thank you, sir. Sir, myself, Lavan Srikya. I am from NIT Meghalaya. And today I am presenting my project, Rosy Resistance, where every part has a purpose. Our idea here is to transform this into underutilized plant, Rosy, into a complete ecosystem of health-rich, natural gas and sustainable materials. This project combines chemistry, material science and sustainability to create a circular bioeconomy model aligned with global SDGs. Currently, in underserved communities lack access to nutrient-rich functional beverages and rely heavily on sugar-rich synthetic drinks. At the same time, industries like food, textiles, and cosmetics still depend on synthetic dyes and petroleum-based materials, which are harmful to the environment. Despite being apparently grown in Northeast India, rosary is mostly sold in raw form, and a large portion of the plant is wasted. Farmers, women, groups also lack access to processing technologies and market opportunities, limiting their income potential. Now, our vision here is to build a circular bioeconomy of the plant, which is known as rosary, where no part of the plant is wasted. We aim to convert every component into a high-value product, food, materials, and biowaste chemicals. As you can see from the cabbage, we can make some herbal type of products, and from the cabbage, we can make some health drinks. And from the wasted product, there is a step of this plant. We can make some. We can extract the fiber, and by mixing with the polymer composite, we can use the polymer composite into different types of applications. Now here we are proposing 4 integrated product platforms. First, a nutrient-rich rosary juice. Second, a rosary tulsi herbal tea. Third, an encapsulated anthocyanin complex or natural colorant. And fourth, and our final product is the advanced polymer composite using rosary fiber. And together, this creates a complete value chain utilizing every part of the plant. Now let's talk about our first product. In our the first product of ours is a user enhanced rosary juice, rich in anthocyanin, polyphenols, and vitamin C. The key innovation here is a multi-layer protection system for anthocyanin, combining free and encapsulated pigments along with 4 antioxidants such as ginger. Our preliminary results show excellent microbial stability for up to 4 months, stable pH, and a high consumer acceptance in terms of taste and color. Going forward, we plan to optimize extraction conditions to preserve nutrients, fine-tune the pH for maximum stability, and incorporate micro-encapsulation using food-grade materials like marco depth. We will also reduce synthetic preservatives by developing a natural antioxidant system. Packaging and temporary optimization will help us handle technical and market-ready formulations. Now, if we discuss about our second product, we have in a biodegradable tea. We combine the antioxidant properties of rosary with the adaptogenic benefits of tulsi. We will optimize drying condition and blend ratios to achieve color and health benefits. Here, the goal is to create a premium, sustainable herbal tea with strong consumer appeal. Then the third product focuses on extracting and stabilizing the anthocyanin using this chemistry. We use natural yeast, eutectic solvents, enzymatic nutrients, and ultrasound resistant extraction to maximize the yield. The pigments are then stabilized using food producing a stable powder that can be used in food, cosmetic, and advanced application like a solar cell. Now, the preliminary scientific evidence on compounded presence is physical anthocyanin for individual spectroscopy and FTIR analysis. As you can see, you are that we extract anthocyanin by using water and we also analyze it by UV spectroscopy, and this is only the left side of this slide. And we also characterize the anthocyanin pigment by using FTIR spectroscopy. Now, the fourth product utilizes rosary stems to develop an advanced polymer composite. Our study shows the rosary fibers have high crystallinity, good thermal functionality for reinforcement. We are developing hybrid composite using both thermoplastic and metal for etching, packaging, and automobile and petrol. Independent by the process is composite from mechanical effects, multi-stability and humidity. Techniques like tensile testing, EVA, we have identified high-performance materials. The goal here is to develop the equilibrium by object automatically to petroleum related materials. The entire system is designed as reduced models in and pigment system from fibers and composites and residual waste for compost or other activities. This creates multiple revenue streams while minimizing the environmental impact. Now let's talk about business model. Our business model follows a existing model. We sell vaporization tea directly to consumers while applying pigments and composites to industries. Similarly, we plan to license our technology in diversified model ensures sustainability. We have discussed our A24 roadmap of projects, stage focusing on optimization followed by prototyping and testing. The third stage involves feasibility studies and benchmarking. And finally, we have moved to patenting, testing and commercialization. Now what is the impact of project? This has a strong social, economic, and environmental impact. It improves nutrition, generates rural employment, and employs reduces dependence on increasing materials and contributes to multiple activities, including health care.
I think these are okay. These are okay. Very nice you brought in XRD, EGA, and other analysis. Very nice.
Yes.
Just one question. Some of these are already there in the market. So, what is
Sorry, the market food fiber is there. If I talk about the aspect of the fiber that I expected from protein fiber, protein plants. Like the jute fiber is there. The fiber is not like the answer. Yes.
You don't have to answer everything. What I'm saying is, some of these forms are already in the market. So you should look at not just from the scientific perspective. To make it as a product, what else needs to be done? Is there a branding issue or is what we should look at? Okay, otherwise this is good. Maybe it will someday see the light of the day. But definitely worth exploring further.
Okay, sir. Okay.
How do you intend to popularize the rosette as an option?
Yes, sir. Actually, rosette is very famous. Sir, if you search on also, you will find that the rosette article will come named as a tea because it is not a like its constituents are not tea, but we can say it is the article reference and it's very famous among the people. Like in real estate, you will start rosette tea at a very high price. And like if you search on the Google or internet products, you will find it very popular demand among the people. So Indian market is by making in PDF format, PDF format, and every household better in India and like you will do
Okay, I think what's here I want to make a feeling for people.
Yes, it's totally different. It's not very imagine that you will say only Western communication. They used to even like African communication, they get some one name drink that is called as Zomo, which is a of this rotating tea only. Rotating from the rotating tea.
It's to make a idea.
Yeah, right. to read that is known as a master plan, where we used to make this, theory into the defect. So it is very famous among walking Indian people. And if I go to the western like world, and in USA, even in Africa, it's very famous. They used to different kinds of wine quality. Yeah, and even from India. Okay, thank you. Yeah. Perfect.
Thank you so much. Now we have the last
Okay,
speaker.
from my yeah.
You want to say?
Thank you.
Now we have the last speaker for today's presentation. The team is from SNS College of Technology.
Just hold on, we are just Lago, can you just hold on? Lago, can you stop sharing this screen? Great. Very good.
Yes.
Start sharing your screen.
Sir, it's visible.
Yes.
So we need the lesson activities. So we are from SNS College of Technology. So our team name is the Innovators, and my teacher is assessment. So we are going to take the topic as reducing the food waste. So it is nothing but it depends on the Green Innovation Challenge also. So probably Green Innovation Challenge in the sense we take just not about hunting the plants and animals. So it also includes what we give to the nature and what we take from the nature. So we choose the topic as reducing the food and vegetable waste, which is really spoiled due to many process. Like, for example, why we choose this problem is nowadays you can see example in the roadsides you can see many foods or vegetables for spirit.
Which slide are you on? Go ahead.
So this is a problem statement, and my team will explain.
Problem statement is very clear. Go to your solution.
We clearly identify the exact problem, get the fruit and vegetable college. After interacting with the vendors, farmers, and the fluoride handler, we understood that spoiling is usually detected only after the visible damage occurs, which leads to the major economic loss and food waste. The core issue is lack of real-life monitoring systems that can detect early signs of spoilage during the storage and transportation. We explored ideas.
You're still on slide 3.
Slide change, please.
Why we change the slide to the slide? Sir, sorry to the convenience, my network issues.
Okay, you are trying to. No problem, don't worry about if you not, you have problem with the slide, just tell us the solution.
In the meanwhile, kindly, you can try sharing your presentation with me. You will see my name as Akshay in the note.
So, we define the track, a smart forest chess system that uses a camera for visual analysis, sensor, and integrate AI system. We use the TensorFlow AI, which detects the real-time monitoring issue which is in the two-type database. So, Balaji will explain the workflow of technology.
Where is that data? You only explain, don't worry.
So you can explain however you know, don't worry about it.
So, we can role model which small scale UC owners can use effectively. It is available in the large scale, but we focus on the small scale because the farmers need many of storage during this temperature and the humidity. So we design our project in the base of the design thinking, that is 5 pillars. We call it as empathy, define, ideate, prototype and test. So prototype based on the 5 steps only. So first we design the model. That is design of.
Hold on. I think we understood the concept. So you said we have a prototype. You want to just show us the prototype? That will be better.
Yes, sir, we design the name.
Okay, that is the modern design slide. Can you make it little bigger? Now to see the. Okay, so you connect the ESP32 to your system and then you measure. Okay.
Yes, sir. So,
next slide, go to the next slide, please.
Yes, sir.
This is the design for your prototype.
Yes, sir.
Okay. Wonderful. What decides the whether is bad or good? How does that information is given? Captured.
So we have the criteria sequence like sir. So our step our treatment right and protein. The school is kind of
Are you saying multi-spectral analysis?
there's some multi-spectral thing like what
Using the visual analysis, not multi-spectral.
yes sir, not all.
You are just doing a visual analysis.
Sir, it is the name of the link. It avoids some.
Okay, got it. So in addition to that, we also have a VOC sensor there.
See, some gets volume, makes the gap, everything gap, property of it.
Got it. So you have a concept that is done, design that is done, and you are still trying to make a product of that, right?
Yes, sir.
Wonderful. I don't have any other questions. If you want to add anything to already what we have discussed, don't worry about the prototype design now. Already achieved.
Okay.
So what's the next stage you want to do?
So,
Go ahead.
so we're going to create a mistake for this. So please, Windows can easily access the system by doing this. This is other systems. This is a major profit of the system, and it is backlinked. We can the first word that we can add 1.5 kg of system in one of the factors.
Okay. I think these are okay, the plan is okay. I think, even for testing, you should throw in for guidance and other things. First you try to make a prototype and then see how your AI can fit well, right? So that means what is the positive performance that it can catch and you should do that. I don't have any other questions. Do you have? Yeah. Okay. I think that's all. We have nothing else to ask. Finally, and we didn't get the name of your teammate, but so nice of you. You are third in the list, but then you waited. Your consistency is very good. Waited till 8 o'clock in the evening and you logged in and explained your problem. So nice of you. Thank you very much. Thank you. Good luck. Don't stop here. Take it further.
Okay, so we will
Thank you. Bye. Still waiting.
So now let's come to the part where we all are waiting for. So this was the second, one of the biggest competitions organized by the Teaser Anatomy Meghalaya in the last year since its inception. We have around 145 registrations, 145 teams registered across India, including IITs, IIMs, and NITs who are taking part in the first round. The shortlisted, and out of that we received about 30 to 40 abstracts, and 15 to 16 shortlisted teams are presented today. So now, now we will move to the most anticipated part, and I will call out all three judges to kindly announce the results.
Thank you all for a wonderful evening. You all have really delighted us by the breadth of the scientific approach, the technologies used, and how you will apply in taking these innovations into the market. And I congratulate everyone who presented today.
All contests will have a few winners, and I think we should, before we get into the winners, we should applaud for all of you. So congratulations. Keep up the journey, and as I said, this is not a journey for today. You just don't start with an app, a website, or a product. You need to go win in the market and make sure you make the big dent. Starting with the third prize, we have joint winners. The first joint winner for third prize is University of Jammu. Very, very good effort. And joining University of Jammu at third place is Plabon Saikia from NIT Meghalaya. Congratulations, Plabon. Very, very well done. Plabon is online in NIT Meghalaya. And the second place goes to Northeastern Hill University, Shillong. Very, very good effort. What I really appreciated, what we really found very interesting about the team is their ability to explain the nuances of technology. There are a lot of advanced technologies that are being used, but why are we using, where is the nuance of where it will work, where it will not work? I think I congratulate your ability to bring that out, and that's something that and identification of problem. So congratulations. Please put in all the effort. We wish you all the best, and we look forward to hearing you make much more strides as you go forward. And at number 1 is the teams from ISET Tirupati. Very, very well articulated pathways of solution, understanding limitations of what can be doable today, taking that back step and saying that maybe we have to work with other devices and build on the software side much stronger. I think that flexibility is what every innovator wants. It's not, I mean, sometimes we obviously believe that our solution is the best solution, but sometimes we need to kind of listen to what people around us are taking and trying to do things that are more acceptable friendly. And then I'm sure the device will also pick up. So congratulations, ISET Tirupati, Northeastern Hill University, Plabon from NIT Meghalaya and University of Jammu. Wish you all a very, very huge success in the days ahead. And congratulations to all the teams that have taken the effort to apply, send in your nominations, send in your submissions, and also presenting today. Thank you very much. Since you are here, we would like to invite the team Nego to come join us. Round of applause, please. Come on, guys. Picture random. Everybody. Come.
Right, mobile.
Come up. If you are really photo shy, then you can at least leave the photographer and send it.
Very, 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 very Very good.